Hello, hello. Welcome to another Floaty Boat stream. Hey, Simp. Yeah, I didn't stream yesterday. I had kind of a business meeting thing I had to go to, so unfortunately it couldn't start on Monday. But, we're back. Today, we're not going to be playing League of Legends. I'm a little bit burnt out of the game. So, I thought we'd dive a bit into some programming stuffs because that's something else that I like doing. And I kind of figured I'd go through some basic game development stuff, kind of show people like how it works, show that you don't need like a big team to make a game. You don't really need like artists or like digital media artists or like music artists or anything, at least to begin with, to like start making your game and stuff. Like you can use just HTML and JavaScript to get started with something pretty simple. And you don't need like a web server. You don't need like Node or something, which is like another kind of server. Like all you really need is a browser like Chrome and then like a text editor like Notepad or something. Like that's all you really need. And then you just learn like HTML, maybe a bit of CSS, and then JavaScript. And like it's that simple. So figured we would jump into it. I have a text editor called Zed. There's nothing like too crazy about it. It's the same thing as Notepad. I can just see like my project files here. And then to actually like run our files, we're just going to open them in Chrome. So it should be really straightforward. That's cool, man. Like I'm just here to show like anyone can make a game. And Pirate Software, right? We I think we kind of figured out he's sort of a scam or whatever. But he did speak a lot of truths about the gaming community, where like you really should just start making games. Like don't overthink it. If it doesn't go too well, just keep going. Like you're gonna keep learning stuff. Just go until like you can't go anymore. Because even if you're like, my frame rate isn't very high or something like that, like that's cool, man. Just keep making it because you're gonna hit other obstacles that you're gonna have to think about as well. And you're gonna have to resolve those eventually as well. So if you hit the obstacle of my frame rate isn't very high, and then you completely start over, then you're not going to be thinking about this other thing down the line that's like, oh, well, actually, my collisions aren't going to work the way I thought they were either. And that's going to completely change how I write the engine of the game because, like, so and so with the frame rate and all the whatever, like it's all intertwined. So if you have one problem in the future after the frame rate thing, it might change how you fix the frame rate thing as well. So I really suggest you just keep going and going and going and run into as many problems as you can, and then take some time to like look things up, figure out what you can do about it, and proceed after that. But I'm just going to show you how to do like a really simple HTML and JavaScript game. I kind of expect you to know JavaScript. The HTML and like tiny bit of CSS that I'm writing, you pretty much don't even need to know what it means. It's pretty self-explanatory. But yeah, I guess let's just get into it. I'll try and explain the JavaScript as I go too. So if you don't if you're not incredibly familiar with JavaScript, maybe you can kind of figure it out with me anyway. But anyway, I just have this folder on my desktop called HTML.js game. It's just a regular folder. I haven't done anything special to it. And I've just opened it in my Zed editor. And so we're going to start typing some HTML. We're going to say doc type HTML. And that just basically tells your browser we're going to be using HTML5 because HTML5 has a canvas element that we're going to use to draw our game. And that's going to make the development a whole lot easier. It already has some built-in functions and things that are going to allow us to draw to the screen. It has like an internal resolution, so we don't have to worry about that. You know, a lot of like technical game development stuff you probably don't really need to worry about right now. I forgot I was gonna play some music in the background too. Let me get that going. Mostly because I want to listen to it, but okay. All right, so we're using HTML5. We're going to be using the HTML canvas. And let's get started. So we're going to make some HTML. Inside the HTML, we'll have a head, which we're probably not really going to be doing anything with, but that's okay. And then we're going to add a tag called script. And this is going to be where we're going to put our JavaScript for now. So just to help specify, I'll put type text / JavaScript. And this is essentially a explicit declaration that this is going to be JavaScript. I'm pretty sure that's how you write it. It might be text / JS, but it doesn't really matter. The default for script is going to be JavaScript. So even if you don't put this, it'll still run as JavaScript. And then in our body, we're just going to put a canvas like this. And we are most of the way there. I'm going to make a style tag. This is going to be some CSS. So we'll put our CSS here. And you don't necessarily need CSS to get this to work either. But I'm going to add some just to help with displaying it on stream. So what we do need on our canvas is going to be a width and a height. And you have to do this in HTML. You cannot do this in CSS because this is setting the internal pixel resolution of our canvas. And if we do it in CSS, it's just going to stretch the pixels of our canvas, and we don't want that. So let's say for width, we'll try like 900. For height, we'll try 600. That's a pretty standard resolution for some smaller games. And we'll just kind of see what it looks like after that. We're gonna target the canvas in some CSS. We'll give it a border of 1 pixel, solid black for now. And yeah, let's keep this open. Did it? Yeah, it auto formats. That makes me cry. All right. So in order to open this, we're just going to open our folder. So we have our folder here. You're just going to right click the file, say open with, and then pick your browser of choice. So I'm going to say Chrome. And there we go. This is our canvas. It's kind of up in this corner, so you can't see the border of the top or the left. but you see the 1 pixel border we've made, and that will let me kind of adjust this so I know how big it needs to be for the stream. And we'll just go like this. And pretty much the rest of our day is probably going to look like this. So I'm just going to put a margin 0 auto. I think there's a shorthand for it that's just 0 auto or something. But now, maybe try display block, something like that. Yeah. So now I have it centered in the middle here. And then I'm just going to put a margin top of, well, I guess we can put it in with the other margins. Leave this as the top. Let's do like a 15 pixel margin. Yeah. So now we're a little bit from the top, we're a little bit from the edges, so you can actually see the canvas itself. To make this even better, I think we'll add a background of white here, and in the body, we will have a background of black. And if this works, then we can just remove the border altogether. Okay. And then let's open the console. So you can either go in here, go to more tools and then developer tools. Or what I like to do is Control-Shift-J will open you directly to the console of your page. And this is where we're going to output things to the screen from our JavaScript. So we're just going to move this up here, kind of frame the canvas a bit. And we are good to go from here. I'm just going to close this, save us some space. But that's what it looks like, again, if you're wanting to like copy or whatever. But all of this is just basically putting this somewhere else on the page, making the background black and the foreground white, all that stuff. It's really not that important to have the CSS because we're not going to be touching it from now on. So let's just close the head altogether and let's start on some JavaScript. So in order to do things with this canvas, we have to have a way for JavaScript to interact with it, like know what it is. So we're going to give it an ID, and we're going to call it, like, I don't know, we'll just call it canvas. Straightforward enough. So we need to make a variable that references this canvas. And to make a variable in JavaScript, you can either use var or you can use let. And you really should use let for most cases. I believe var is like a global variable setter, let is a block level setter. It's kind of a technical programming thing. You don't really need to know much, but anyway, we're going to make it called canvas. And we're going to set that equal to document get element by ID canvas. So what this is doing is it's saying on our HTML document, which is in here, we're going to get an element with the ID of canvas. So if we look in our HTML, it says, hey, there's something with an ID of canvas here. So that must be what you're referring to when you say canvas here in JavaScript. Nice. We're doing some game development today, Chili. Didn't really feel like League. Kind of felt like programming. I haven't written anything in a while. I'm getting a little rusty. So we're just making a little HTML game. I think we'll probably make a clone of a game I've made before called Cube Wars. I think that'll probably take us a couple hours. Especially if I like stop and talk every now and then. But yeah. So let's proceed, I guess. So now we have a reference to this canvas, but we can't really do anything with the canvas other than make it bigger or smaller or change the background or something right now. So we need to get the inside of this canvas. We need to be able to edit the pixels that are inside of this canvas. So we're going to make another variable. I usually call it can, some people call it G. What do we feel like today? I think we will call, some people call it CTXT because it's the context of the canvas is what we're getting right now. I think I'll just call it can. So we're going to call that canvas.getContext. And then a string inside, we're going to say 2D. So why 2D? Well, because it also has 3D capabilities, if you didn't know that. I personally have never played around with the 3D stuff, but it seems pretty cool. So we're just going to use the 2D stuff and kind of go from there. Now, we have this reference to the canvas. We don't really need this anymore. If we wanted to, we could do something like this and just chain them together. So we're going to get the element of canvas, and then we're going to get the context of that element. So it's just kind of a shorthand, since we're never going to target the canvas after we like do this. We're only going to ever talk about the context of it. We're just going to chain it together like this so we don't have another variable floating around. So what can we do with said canvas and its context? Well, you can say can.fill rect, and let's do like 0, 0, 50, 50, and see what happens. Let's refresh the page. Now we have this corner blocked out. Why is it black? Why is it like merging in with the background? Well, because at x0, so if we're going left to right, 0 would be here. And then y0, and y is actually upside down in computing if you're looking at like an xy axis. So up on the y-axis is actually down on your screen, which is really interesting, and I think has to do with how pixels are drawn to your screen, is why we like designed it that way. So 0, 0 would be here instead of here because the y-axis is flipped. And then 50 is the width and 50 is the height. So we made a box that is 50 wide and 50 tall in pixels. Now, that's cool. We don't really want it blending in with the background though. So what can we do? We can say can dot, I believe it's fill color. And then trying to brush off some rust. Can I just do like blue here? Does that work? It did not work. So we're gonna go to Google and we're gonna say ctxt fill color JS. I think it might be like set color. Fill style, maybe? Yeah, I think it's this fill style here. So we're gonna fill style, and we're gonna set that equal to blue. It's been a minute since I played with this. So now when we refresh the page, we have a blue rectangle that does not blend in with the background and stuff. Now that's cool. Let's maybe move it in like 25 pixels each way. Boom. Now it's not in the top left corner because it starts 25 pixels in on both sides and then it draws width and height to 50. So yeah, now we can kind of move this around. We can change the size of it or whatever. Like these don't have to be the same. You could say this is like 70. We'll put this at like 100. Boom. So now it's 100 pixels down. It's 70 pixels tall, 25 from the left, and 50 in width. So pretty simple. And we can do a lot with this. But other than just like drawing a bunch of squares, I believe there's also a draw rect. So if I said like 100, 160, 70, something like that. It's not draw rect. Fill rect, only border, ctxt, JS. So, stroke rect, that's what I'm looking for. So if we refresh now we just have a square that I drew that is not filled in. It's only the border. So that's something else you can do. And you can like overlap things as well. So if I made another rectangle or square or whatever you're making, if I put it in like the same place, we'll say it's like 40 pixels instead. Now it looks wider, but if I change the color to be like green, you'll notice that this green one is actually on top of the blue one. And I'll even shift it down a little bit so that we can see that a bit better. There. So you see this green one is actually on top of the blue one. Now, there is a priority in that to see which one is on top of what, and it's whatever was drawn last. So I drew the blue one first, and then I drew the green one after that. And that means that the green one is going to be on top of the blue one. So that might come in handy if you're trying to do like a parallax background or something. You're trying to have your background in the background. You're trying to have your character in the foreground, you know, that whole thing. So you're going to want to draw all of your backgrounds and things and then draw like your character moving around and stuff. So that's something important to keep in mind when you're making a game, is always do whatever's in the back first and then do the front. Yeah, so let's just comment some of these out so you can still kind of look at it, see what we've been playing with. And let's move forward. So now you're like, okay, cool. We have something like we have a canvas, we can draw on the canvas. Like, how do we make this into a game? Well, first thing we're gonna need is a game loop. So we are gonna make a function and we'll call it update. And we will make another function. We will call it render. And then we're going to make another function. We're just going to call tick, something like that. This function is just going to call update and then call render. So it's not incredibly important what it's called. This is just kind of a simple way for me to break up the logic that's going to be updated and then the graphics that are going to be updated. And the reason I'm writing it this way is because this is a very common practice in different languages, not just JavaScript. For like C++ or something, let's say you're using SDL2 as like your graphics framework. So SDL2, you're going to write all of your SDL logic in here, and you're going to write all of your C++ logic for how the game's running in here. And these would generally be in like two different classes, like a world class and then like a window class or something. And we might get to something like that if we keep working at this game. But I'm trying to keep it really simple so most people can follow along. So yeah, we're gonna kind of move forward. In order to have this function go at a regular time interval though, so that it loops, we're gonna do set interval. I spelled it wrong. Okay, and then this is gonna take a function. We're gonna say tick, and then it needs a time in milliseconds that it's going to wait before it runs the function. So milliseconds, 1,000 milliseconds is 1 second. So if I want my game to refresh the logic and the graphics 60 times per second, which is kind of the standard for like FPS games and things, then I would do 1,000 divided by 60. And we can leave it as this. Browsers are a bit limited on resources. And so if you're not able to do 60, you can lower this to like 32 or something like that. Like this number is whatever you want your frame rate to be, essentially. And this is going to be like a single thread application. If you understand what multi-threading is, JavaScript is a single threaded like script engine. So you can't do multi-threading in JavaScript. Regardless of how much they try to make you do async and tell you it's pretty much the same thing, it's not. All the async does is reorder the time that it does it. It's not doing it at the same time. So just keep that in mind with JavaScript if you're trying to overcomplicate things. Like no matter what, it's a single threaded application. So, but there's nothing wrong with a single threaded application. There's tons of major games that were single threaded applications. But now we're doing something every 32 whatever, like every second divided by 32. So 32 times a second we're doing these things. But what do we want to do with these things? Well, let's say we have a variable we're gonna make, and I'm gonna say like x is 0, right? Okay, well, what am I gonna do with that, right? Well, in render, I can say on my canvas, I want to fill a rectangle. I want to do it at the x variable we made. Let's put it at like 25 from the top, and then we'll just do 50-50, right? So when I refresh this, we have this black box. Let's change the color again. We'll make it blue. Okay. So now we have this blue square, at x is 0. Well, we know if I change this to like 50, it's going to move it to the right a little bit, right? So what if we start it at 0, and then in this update function, which comes before render, that's really important. You really want to update and then render, which is one of the reasons that I did this like separately like this, and why you want to separate your logic between your like maths and your graphics. So what if I said x plus plus? This is the same thing as saying x is x plus 1. So we're going to make x 1 more than it is every time this runs. Okay, well, what does that do? Well, we have this like progress bar now. Isn't that crazy? Well, the reason that we have a progress bar is that it draws the square, right? And then the next time it goes to draw the square, it says, well, I need to draw the square 1 pixel to the right of where it was previously. So it's going to draw it again. And because it drew it again, it's overlapping the last square we drew. So eventually it's square, 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 square. It just keeps going and overlapping the previous square, but they're all the same color, so it just looks like a bar, right? Well, we don't want our graphics to... Let's actually do something else to kind of demonstrate that as well. Let's make a y variable, and we'll do the same thing. So we'll say y plus plus, and we'll set this to y, okay? So now it's going diagonal. Now you probably see more that we're drawing a square over and over and over again. So now we have this like diagonal progress bar, which is kind of cool, not gonna lie. But yeah, we don't want this, right? So there is another function that the canvas can do called clear rect. Now, if fill, let's say, is like a marker, right? You're drawing inside wherever you're filling. Clear is like an eraser. So you erase whatever is in the square that you're going to designate here. Well, we're just going to say 0, 0, and then 900, 600. Why 900, 600? Because that's the size of our canvas. So what this is going to do is every time it comes through this loop, it's going to clear everything that we have on this canvas, and then it's going to draw again. And what that's going to do is fix our progress bar. So instead of a progress bar, now it's a square that every time it's drawn, it deletes whatever squares were already drawn, right? So now it just looks like the square is moving, doesn't it? Well, it's interesting that it looks like it's moving. That's because movement in a video game is actually a lie. Things are not really moving in a video game, they're teleporting. But they're teleporting such small increments of space that your brain views it as if it's moving. So we have 32 frames per second here. What if I made it 60 frames per second, right? So because our update is also tied to our render, it's also updating 60 times per second, but it's going to draw this a lot faster, and it looks like the movement is a lot smoother, doesn't it? So your render loop, the faster it runs, the smoother you can make your animations. And the smaller increments you do in your update, the more smoother your animation is going to look. So I keep refreshing the page just to keep the square on screen, but we can also do other things with this where we can say, like, if this hits, we'll say the boundary of the canvas or something, we can have it inverse the increment to a decrement, and we can have it bounce, and we could make like that DVD logo thing where it bounces around the screen, right? So what do we like wanna what do we want to do here? Let's demonstrate that, because that's a pretty decent way to explain velocity in a game. So we have x is 0, y is 0, so it's starting up here. We know that. We know that by default we're going to be incrementing it, which is going to make it go this way, right? So when it hits the edge, we're going to want to decrement it. And so we should define some other things. We'll say the width of the square we're drawing is 50, right? And we'll say the height is also 50. And let's change this to width and this to height so that we can play around with some numbers. Now we also want a velocity. So we're going to say the x velocity is going to be 1. And the y velocity is going to be 1. And this means we want it going 1 pixel to the right every frame. That's its velocity. The y velocity, we want it to go down 1 every frame, right? It's the same thing that we're doing here, is the x is going up and the y is going up. So I'll show you why it's important we have like a separate variable in a second. So normally we wanted to increase the x position, right? So we're going to say x equals, and we'll say x vel, but we don't want to equal to it. We want to add the velocity to it, right? So we're going to plus equal. This is the same thing as x equals x plus x velocity. So this is just a shorthand where you don't need to write the x again. So x is what it previously was, plus whatever our x velocity is. And then let's do the same thing with the y, but with the y velocity. So if we just do it now, we get exactly the same thing we had before, right? And when it hits the edge of the screen, it's just going to keep going. So we wanted it to bounce when it hit the edge of the screen, though. So after we do this logic, we need to say, well, did it hit the bottom of the screen, right? So we need to say if y is greater than, and we'll say equal to, because why not? And then our canvas is 600 pixels tall, right? So we'll say 600. Then we want the y velocity to be the opposite of what it was before. So we're just going to put a negative here, right? You could also multiply it by -1, you know, whatever you want to do there. But what is this going to do? Well, if we refresh the page, we're going to watch the square come all the way to the bottom, and then it should bounce. And it did bounce, but it bounced kind of weird, didn't it? Because it went all the way until it was off the screen, and then it bounced, right? Yeah, isn't that strange? Well, that's because the y position is the top. It's the top corner, right? So what we need is whatever the corner is plus how tall our object is. So we need to say, well, our y position plus our height, if that's greater than 600, then we want it to bounce, right? So let's look at that. Nice. That's exactly what we were going for, right? But now it's not bouncing off the right side. So let's do something similar for the right side, right? Well, the right side is going to be our x position. So we'll just say, okay, well, if x is greater than or equal to 900, because that's our width, right? Then we want the x velocity to be minus x velocity, right? And let's run that. So it's going to do our y bounce that we know works. Cool. And all right, same thing. So it's going until it's off screen and then bouncing. So how did we fix that before? Well, we decided that the corner of the box is the origin, or where we're doing our x and y position. So if we want it to bounce off the right side, then we need to add the width of whatever we're bouncing, right? Same as the height did on our y. So we'll say width, and we'll run it again. So it's going to fly down. It's going to hit the bottom, bounce. It's going to go to the right. It's going to hit the right side, bounce. Nice. And then it's gone. It didn't bounce. Well, unfortunately, you have to have a condition for each edge of the screen because you need to contain it in the screen, right? So we already have a y here. We could add another if statement here and say if y is less than 0, then we're gonna inverse the thing, whatever, and then if x is less than 0, we're gonna inverse the thing or whatever. But because we already have this logic, we can just say if y is less than 0 or if the other thing happens. So if y is less than 0, meaning it's above the screen, then it'll do this. Or if it is greater than the screen, then we will do this, right? So we can do the same thing with x. If x is less than 0 or that, then we'll do that, right? So if we refresh the page now, okay, we're going. And it's going to bounce, right? And then it's going to bounce, right? And then it's going to bounce. So that's working. Is it going to do it? Oh, bounce, bounce. Nice. So we've hit every edge of the canvas and it's bounced, right? So this will infinitely just be bouncing around like this from now on if we left our code how it is. And that's fucking awesome, right? So that's kind of a demonstration of how velocity works. And we can increase the velocity too. Let's say it's like 7, right? And we'll even change it. So the y is going to be 5 and the x is going to be 7, right? Or actually, for meme's sakes, 6, 7. Okay. Boom. Now it's going really fast in both directions because we're incrementing it by 6 and 7 instead of 1. But it looks kind of jarring, doesn't it? It kind of looks like it's like bouncing around and like it's kind of blinky or whatever. That's what I mean, where the higher your frame rate is, the smoother this animation is going to look. And if you don't have like hardware acceleration enabled on your browser, that will help this. At least usually. But you have to keep this in mind, is if you have a high frame rate, this is gonna look smoother. Let's even do like let's try and stress my computer out a bit. Like, it kind of looks a bit smoother, but it's moving faster, right? So what if we lowered this to like 3 and 4? Okay, it's back to looking a bit smoother, right? So we're still jumping more than 1 pixel every time we update. But we're not jumping so much that it looks like it's teleporting. And then we're refreshing enough that it kind of looks smoother, right? So this is kind of the struggle in game development, is how often do you want to update the game logic of your game, and how often do you want to draw what's going on in the game, because they're two separate things and the drawing relies on the updating, right? So for a browser game, I really do recommend like 32 or something. Some people are going to be playing on not great hardware. And you know, it's you're going to want your game to work pretty smoothly on pretty much anything that you're making or anything you're playing it on, right? So yeah, we're going to change this to 32. At least I am. You could set it to like 60. And then, you know what, let's play with some numbers. So if I say this is 32, and I want to move, we'll say like 3 pixels this way and 4 pixels this way. It's a little bit jumpy. Like, we could maybe up the frame rate to like 40. I don't know, maybe we'll do 60 just to like keep it smooth. But you just need to like keep tweaking these numbers until it looks smooth enough to you that like it looks like it's animated, right? And this still looks animated. It might be a little bit jumpy, but you know, it's good enough for what we're working on. So we'll do 60. Just play around with it, you'll figure it out. There's not really a correct answer to frame rate or anything like that. Yeah, what do we want to do next? Well, these variables, right, I don't really like that they're just out here in essentially the global space. If I went in here and said like X, it'll tell me what X is, or Y, it'll tell me what Y is. These are just like globally set on my page, and I don't really like that. So what we're gonna do is we're gonna make an object. I'm gonna say let, and I'm gonna call it player equal, and we're gonna open some braces. And then in here, we can actually set some values. We're gonna say x0, comma, y0, width 50, height 50. And you'll notice I'm using these colons instead of equals. That's because this is inside of an object. We're setting properties of the object. And then we'll say xvel is like 3 and yvel is 4, right? And we don't end the last one with a comma. This is kind of like a list that we're making. We're just doing it on separate lines. And then we're just going to delete all of these. So if we try to run it now, oh, it's not going to work, right? That's because these are still looking for like a global variable instead of the local one that we made to the object, right? So if I say player dot x, player dot vel x, now it's going to know what these are. So I'm just going to copy player dot and I'm going to put it before all of these variables that we have. Make sure it's after the negative here. Okay, so that's all of our logic being updated with the player, right? So now when we refresh, we still have an X somewhere. Where? Oh, where we're drawing it. So player.x, player.y, player.width, and player.height. Okay. All right. So now when we refresh, now it's back to normal. Because we're doing player, which is accessing this object, and then inside of this object, we're looking for x. So x is here, x is 0, so that would be 0, right? And then same thing for x velocity, y velocity, all that. So if we wanted to, we could also make like a little, actually, you know, I think we're going to break this back into canvas and can. Let canvas equal to this, and then this will be canvas dot get context. And the reason why I'm thinking about this is because we can get the width and height of the canvas and we can use that instead of these numbers. We really want to minimize the number of just outlying numbers in our code. We want to transform them into words as best we can, because if I'm just looking at this, right, I'm like, well, why is this 600? Why is this 900? Why is that specifically that number there, right? But if this was, you know, like, was it like canvas dot height or something like that instead of 600, then we know, oh, well, it's the canvas's height instead of just a random number, right? So I believe a way that we can do this is offset height, which is something that's already defined by an HTML element. And then we do canvas.offset width here. It broke it into multiple lines there for some reason. I don't really like that. Some auto formatting stuff that isn't my favorite in Zed. You know what? It wants to do that, so I guess that's what we're doing. I don't know why it's not breaking this one to another line, but, you know, whatever, I guess, Zed. You do you. I hate you, Zed. Oh, is there a way I can turn off auto formatting? Let's Google it. Disable formatting Zed. To prevent Zed, add the following to your settings JSON. And turn off formatting for specific languages. Okay, where's my settings JSON? To disable settings in Zed editor, you need to modify your settings. You can open this file, opening the command palette. I believe that's this. Maybe not. The command palette would be run, maybe? No. Oh, you can open it by Control-Shift-P. Okay. And then type open settings. Okay. Format. On save. Off. Nice. Are we good? Can I change this now? Nice, it worked. Okay. A little bit of tinkering with our editor. I think it's trying to wrap it because we're getting close to the edge of my screen, and so it doesn't want us to go off the screen horizontally. It wants us to still be able to see all of our code. So it's really a good thing on Zed's part. I just don't like it by default. I don't mind things going off the screen to the right, and then I'll just scroll to the right to see it. Like, I don't have an issue with that. So, okay. So we have the offset height and offset width working, I believe, because I'm pretty sure I refreshed this. Yeah. So now we don't have random numbers here. We're gonna also put them in here. And then 0, 0. I think we'll just leave it. Like, we know clearing the rect, the only time we're gonna do that is when we're clearing the whole screen, right? And then it's kind of like a position in the world too, if we like think about it on a deeper level. Like, anyway, it's fine. So now we've made this like bouncing thing, right? Well, what if we want to control the square? We want to push buttons, and when we push the buttons, we want to move the square, like you're controlling a character or player, right? So the first things we're going to do is we're going to set the velocities to 0. We don't want it going anywhere just yet, right? So we're also going to delete our bounce logic. Like, this is pretty cool, making the little like DVD bounce sort of effect. But as far as our game goes, this isn't going to do anything particular in our game that we want. So we are going to leave the incrementing by the x velocity and y velocity, because that is essential to moving your character, right? So now we need to make a way that we can push a button, and when we push a button, this is gonna do something, right? How do we want to do that? Well, let's do a button listener. And how we can do that is we can say document dot on key down. I think it's all lowercase. Anyway, this is something that's defined in your browser in like HTML and stuff. This is something that's already made for you. It already exists. And then you're going to say equals function, and we're going to open a function here. So what does this do? Well, document is our page, right? On key down means when you push a key on your keyboard. And that's going to do whatever you put in this function. So if I go in here and I push a button, it's going to run this function. As long as this page is focused, if I push a button, it will do something. So I'm just going to log I haven't shown you this yet. It's pretty basic, but your console is this thing that I opened here, and we're logging to it, or we're writing to it. I'm going to say hello. Okay. When we refresh this page, I'm going to click a button, and it's going to say hello in our console. So we can push buttons, and we see this number going up because it's printing it multiple times. It's the same thing. So now we know when we push a button, it's doing something, right? But how do we know what button is being pushed? Because we don't want just any button pushed. We want a specific button. We want to do something specifically when like WASD is pressed or like arrow keys are pressed, right? Well, this function can have a it's like an event variable that it takes, and we're just going to call that E. So what if we log E outside of quotes, because it's not a string, it's a variable, right? What if we do that? Let's refresh the page, and I'm going to push D. What is this? We got something called a keyboard event. If we look inside of it, it has is trusted, bubbles, cancelable code, all this stuff, right? But we do see key is D, right? That seems kind of important because the button that I pushed was D. So if that matches the button we pushed, let's try it. Let's try it again. Let's push a different button. Let's push the arrow key right. Oh, it says arrow right here instead, right? So this is how we're going to check what key is being pressed. And you can do this like two ways. One way is you can get this key and you can check the string that's in here. That's not my preferred way. My preferred way is to use this key code, because something that we'll notice if we just clear this is if I push A and I push Shift A, then when I look at A, you'll see key is lowercase a, right? But if I do Shift A, it gives me a capitalized A, right? So if I do it by this key variable, I'm going to have to check if it's uppercase or lowercase. But this key code says it's 65. And if we look at this one, it's still 65, whether it's uppercase or lowercase. So it knows that I'm pushing the A key, and the key code doesn't care if I'm holding Shift or not, but the key variable does. So we're going to use this key code instead, because what if I have like caps lock on, or I'm holding Shift by accident or something, and we're listening for lowercase a, it's not going to do whatever we want it to do when we push A if we're checking the key against lowercase a. We want to check it against the key code. So we're going to say on key down if E, which is this keyboard event, by the way, is E. If E dot key code is equal to, and then the key code for A was 65, right? So 65. Then we want to do something. Let's say log A pressed, right? That sounds pretty good. So let's clear this, refresh the page. So I'm pushing a bunch of keys, but the only time it does anything is when I press the A key. Hey Thanos Bay, what's up? So now we know it's listening for when I push the A key. And an easy way to keep track of what these keys are is you can leave a little comment here and just say like A, right? So I know that this if statement will run whenever I push the A key. Now we're gonna need some more keys. So let's just console log, and we'll say e dot key plus we'll put a dash in there plus e dot key code, something like that. And what this is gonna do is whenever we push a key, it's gonna tell us what the key's called, right? And then it's going to give us the key code after that. So when I refresh the page, I can push A, and it says A65, and then S is S83, D is 68, and W is 87, right? So these are all the codes that your computer uses to identify the keys you're pressing. And these are the like human readable ways that you are going to recognize it, right? But now we have a list of codes associated with the letter we're listening for. We can also do like up, left, down, right, and those are those keys, right? So for each of these numbers, we're going to do an if statement. I like to do it in a pattern of up, down, left, right. So we're going to do up, down, left, and right. And we need to change these numbers to be whatever we want up, down, left, and right to be, right? So up is going to be W. And we're going to change the key number to be 87. And then down was going to be S, which is 83. Left is A, we already got that. And right is D, and D is going to be 68. Okay, and you can do this for up, down, left, right as well. Just know that if, let's say your browser, like if your canvas is bigger than your browser, then when I push right, it's actually going to scroll my browser. So you want to try to keep the canvas smaller than the browser height. And you can do that by resizing it with JavaScript, using some CSS to try and adjust the size of it and keep like an aspect ratio or something. There's a lot of different ways you can do it, but for the standard thing, we're not going to get into it. Just keep a smaller canvas. Your game's also going to run smoother the smaller your canvas is because you have a smaller internal resolution. And to kind of explain that kind of broadly, quickly, is your canvas has pixels inside of it, right? We defined that here, that it's 900 by 600. But I could say that it's, let's see if I can do a quick example here. I could say that this is like 300 by like 4, or we'll say like 200, right? And if I refresh this, it made this smaller, but in relation to the like size of the canvas, our square looks bigger. That's because the square is technically the same size it was before, but our canvas is smaller, right? But if I go in CSS and I say like, well, the width of my canvas is going to be 900 now, and the height is going to be 600, then it's going to change nothing, actually, which is interesting. That is interesting. Interesting. Oh, it's because I didn't say pixels. Okay, now it's doing what I thought it would. So it's taking that little canvas that we made and it's stretching it to be the size of our screen now. So you don't actually have more pixels inside of the canvas, you're just stretching the pixels now. So if you wanted to be really like efficient with your pixel usage, you could say, oh well, the width is going to be like 32 times 6 or whatever. If you want to do like 32 by 32 graphics or something, you can like completely math it out, so every pixel is going to be a unique like color or something in your game, and that'd be incredibly efficient. And then you'd just say like, yeah, well, the width is like 300, the height's 200, but then I want to stretch it so that your visible window of the world is bigger, but the actual world is still small. And like maybe that doesn't make a ton of sense, because like you're kind of just getting into game development stuff. But you know, as you keep working on game development, you'll learn about internal resolution, and the lower your internal resolution is, the smoother and faster your game's going to run, the more frame rate you're going to get. It's the same thing as like adjusting the frame rate here and seeing how that affects how smooth your animations are, right? Is you're just going to have to play with it and figure it out. But if, let's say you have a like 32-bit game or something, so all your sprites are going to be like 32, or that might be 16-bit or something, I can't remember. Anyway, so all of your like characters and things are going to be 32 pixels big. Well, I can make this 32 pixels be let's lower this. Let's say like 100 by 100, right? Now it's like stretching it because we've changed the aspect ratio here. Let's change this like 600 by 600 so it's still a square. So this is supposed to be 32 pixels, but that's a whole lot more than 32 pixels, right? That's because inside of the canvas, this is 32 pixels. But on your screen, we're stretching those 32 pixels to be bigger than what they originally were. Anyway, you can play around with it. You can work it out. It's a really cool thing that you can do to increase frame rate and make it so you're not wasting pixels, processing pixels that aren't unique colors and stuff. So we're going to delete these. We're going to go back to our 600 or our 900 by 600 because it's pretty standard. We're trying to keep it simple, easy to understand. But yeah, I'd really play with that if you can. It's really awesome. So now we can detect keys, right? Because we did all this console logging, we made this on key down function thing, and this is implemented in different ways in different frameworks, like SDL. You can poll events, and so then you can do like a switch on those polls or on those events that were polled, or you can check the keyboard state. Like there's several different ways you can do it in SDL with C++, or in like Java you can make a key listener that you can put on your JFrame. You know, there's tons of different ways to do that. This is how you do it in JavaScript, is you just say the on key down hook of your browser, we're going to hook onto that, and we're going to add some of our own code to it. So what are we going to do when we push buttons though? Well, I want to say when I push W, I want to go up, right? Well, we know up is negative in the y-axis on computers. So I want to say player dot y velocity. We want to adjust the velocity, not the position, because we're already changing the position using the velocity here. So if we just play with the velocity, eventually the velocity is going to affect where the player is drawn, right? So we're going to say the velocity, we could say just is minus 5. Okay. And I'll show you why you might not want to do it this way, but I'll show you this way first. S is going to be down, so player.y velocity is 5. And A, similar thing, but the x direction, we're going to say is negative 5. And then player x is 5. Or, sorry, this is x vel and x vel. Okay, so we're playing with the velocities, we're not playing with the positions. Now, what makes this kind of weird is like it will work. If I refresh the page, I push D, it's going to go right. I push A, it's going to go left. S down, W up. So I can kind of control it. But for one, when I let go of the key, it doesn't stop. But that's kind of a different issue. But the other issue is if I'm holding D, it's going to go right. Hold on, let me refresh this. If I'm holding D, it's going to go right. And then if I push A, it's going to go left. But if I'm already holding D and I push A, it will go left. But if I'm holding A and push D, it only remembers the last button I pushed, is essentially the issue. If I'm holding both, it's not going to counteract each other. It's going to overwrite what the other one was, like whichever one was pressed first. So it's kind of hard to explain in a like non-camera situation. But essentially, I'm pushing this button, and then I'm pushing this button, and it's ignoring that this button is still pushed down, which we don't want. We want it to keep track that we're pushing both of these buttons, and we want to do what both of them should be doing, right? So instead, we're actually going to minus equal this by 5, and we're going to plus equal this by 5. Because that way, when I push this button, it's going to increase our y velocity. But if it was already being decreased, then it'll even out to 0, right? So we're going to do this similarly here. And this is cool. If I simultaneously push both buttons, the square is not going to go anywhere. But if I push right, and then push right again, and then push right again, and like, it just keeps getting faster, basically. And so it's just flying back and forth instead of going the rate that we want, right? That's because we're never setting our velocities back to 0. We're just adding 5 and adding 5 and adding 5 and adding 5. So if I hold D, it's going to be 5, then it's going to be 10, then it's going to be 15, then 20, and it's going to be jumping all those pixels every time we add it. So in the beginning, we need to say, okay, we want the player's X velocity to be 0. And we want the Y velocity to be 0. And then we're going to do whatever increments and decrements need to happen. So at maximum, it will be either 5 or it will be -5 minimum, right? Because no matter what, we're starting at 0. We're not continuing from where we left off last time we looped. So what this does is now we refresh, and it doesn't actually do anything. That is because these are like desynced, which I kind of forgot about. So this adds another layer. Let me take a drink for a sec, and then I'll explain this. All right. So this is called whenever we push a button, right? It's completely separate from our game loop. Now, this is not going to be called as frequently as our update loop. So what's happening right now is I click in here, I push a button, and it says, well, we're going to increase or decrease the velocity, right? And then this is running, setting it to 0. And then it's increasing or decreasing by what is now 0. So it's not moving, right? What we need is we need a middle section here that says we want to see if we're pushing the buttons. But there's no way for us to like combine these two things. I can't just like cut this and paste it in here. Like, it's not going to work like that. So we need a different way of managing what buttons are being pressed. An easy way of doing this, if you don't want to make like a separate class that manages what buttons are being pressed or something, is you can add them to your player. You can say like up, down, left, right, and we'll say this is false and this is a colon. False, false, and false. Okay, so why are we doing this? Because we need to know, is the player going up? Is the player going down? Is the player going left? Is the player going right? Because this logic is part of our like update loop stuff. We're playing with these numbers inside of our update loop. This stuff is completely separate, doing its own thing, which is not good enough for us, essentially. Everything inside your game needs to be part of your update or render loop, or it's going to mess things up. So what can we do instead here? Well, we can say, I know, when we push W, we're going to say player.up is true. Okay. So when I push up, it's going to set this to true. Well, that doesn't do a whole lot, but now there's a connection between us pushing keys and something that's inside of our game loop, right? So we've made some sort of link. Let's keep doing this. We'll say player.down is true. Player.left is true. Not minus equals true, it is true. And player.right is true. True. Okay. So now we have a way to say the player is going up, going down, going left, going right, but it's not actually doing anything because we're not adjusting the velocity of the player, right? Let's kind of play with this. So if I look at the console and I say player.right, this is false. If I click in here and I push D and I check it again, now it's true because I pushed D, right? So we have a way to know if I pushed D, and that's cool. But this is where we need to figure out when we're no longer pushing the button. Because when we push it down, it sets it to true. But we don't want to keep going right if we're not holding down the button to go right. So we need to say when we release the key, we want it to go back to being false. So there's another function similar to this one called onKey up. And it's going to do exactly the same thing, work exactly the same way, except instead of when we push the key down, it's going to run this function when you pull the key up. So we're going to do all the same checks and everything, but we're going to say false instead of true. Okay. So now when I check player.write, it says false. If I push D in here and check it again, it's going to say false again. That's because when I pushed D, it went true, but I had to release D to type player.write. So when I released it, it set it back to false. I guess an easy way to show that is I could say like console.log player.write. And I will put this in here as well and refresh. So now I'm clicked inside the window. I push D, it sets it to true. I let go, it sets it to false, right? Down, up, down, up. And that's our player.write that it's checking. So now that you know that it's working, we can practically completely ignore these two functions. Like, we're never going to touch them again unless we add more keys to our game, which we will eventually, but it might be a minute. So now we are able to see if the player is going up, down, left, or right, right? So here, we're going to have a section where we're now adjusting the player's velocity and stuff before it's added to the position. So here is where we're going to have if player.up, if player.down, if player.left, and if player.right. And so this is if the player's up key is being pressed, if the player's down key is being pressed, left and right, right? So now, finally, because everything's wrapped up in our game loop, we can do our velocity changes. We say player.vel y minus equals 5. I did yvel, huh? Yvel. So player.yvel plus equals 5. Player.xvel minus equals 5. And you don't have to use semicolons in JavaScript. I just like to because all of the languages that I program in do other than JavaScript, but they're unnecessary in JavaScript. And plus equals 5. Okay, so now we've tied it all together. This is between us resetting the x velocity, y velocity, and us updating the position of the character. So if we refresh now, I'm going to push D, we're going to go right, I'm going to let go, and we're going to stop going right, which is something our game couldn't do before because we didn't have the key up listener, right? I can go left and let go and it stops. I can go down, let go, and it stops. I can go up, let go, and it stops, right? What if I hold D and then push W or A? It stops going, right? What if I hold A and push D? It stops going because they're canceling each other out now, right? Like, we've added all of this logic in such like a short span of time that now allows us to stop moving, and it also allows us to counteract other buttons that we're pushing. So I prefer games working this way. If you really wanted to, you could still do it this way, to where you're setting the variables instead of incrementing or decrementing, and you could still say, like, you know, if I push one direction, it basically overwrites the last direction I was pushing. But I don't like writing games that way. I think it's not a very smooth experience doing it like that. So I'm gonna do it this way. So that way, if I'm pushing multiple keys, they all do what they're supposed to be doing. And if I'm pushing like left and right at the same time, we don't go anywhere because they're counteracting each other. But isn't that awesome? Now we have a square that pushing WASD we can move around, right? Like, that's awesome. So what do we do with this now, right? Well, we have a quote-unquote character, something that we can control, and we need it to do things or have like a goal, right? Well, some of my favorite games are like first-person shooters where you have a gun and you're running around and you're like shooting other players or shooting like monsters or something, right? So we kind of want to do something sort of like that. Not 3D, but maybe from like the side where we can like shoot something and have it do damage, and then when it does enough damage, that thing like dies or whatever, right? So where do we go from here? This is where you have essentially started your game engine. Your game works, it refreshes, it draws things to the screen, you have a playable character that, like, you know, your key listeners are here, all that stuff. So you have technically made a game, if you want to kind of stretch the meaning of that. But there's no objective in your game yet, you need to add that. So game design starts from this point forward. We have a character, we want it to do things, we want it to maybe look different, have like a sprite or like an image instead of just being a square, right? So we need to maybe bring in a graphical artist if we are not an artist ourselves and we want something really good. But we're gonna kind of skip graphic artists and like music design and all that stuff. We're not gonna do that. That's gonna take too much time for this simple thing that I wanted to make. But that doesn't mean we can't make a fun game even without those things. I made this game called Cube Wars, which is what we're gonna be remaking today, essentially. And I shared it with my friends in school, and my friends played that game for like the entire year. I gave them the files so that they could play it, and they just kept playing that shit. Every time I walked past their computer in the computer lab, they were playing it on the side. So it can definitely still be fun, and the frame rate is probably better because you're not drawing images and things like that. But yeah, we're just going to be using like squares and colors and things to distinguish between objects and stuff. And we can also write text, which text is a lot more important to a game than a lot of people give it credit. Like, text allows you to communicate with like NPCs and things. It allows you to have menus. It allows you to have like scores and stats and all that stuff. Like, text is so important to video games, and it's very, very easy to add text, at least in JavaScript. Some things like C++, not so easy. But I still think you should add it. It's very important. It adds a lot of feeling to the game. But yeah, I've kind of been blabbing on about game design and stuff. Let's talk about the kind of game that we're going to be making. So we have a player. I want to give this player gravity, and I want there to be like a floor here. And I want the player to be able to jump against gravity and move back and forth along the ground here. And then we also want to be able to shoot like little bullets, okay? And then we also need an enemy that we're going to be shooting bullets at. The enemy needs to be doing something so that it isn't easy to hit, and there needs to be some sort of repercussion if we're not playing the game very well, right? So we are going to make a big red enemy that is going to do our DVD bounce thing around the screen and the floor. And if it touches you, you die. Okay? So you have to avoid this enemy while also shooting it. And if you do enough damage to it, it will disappear, you will win the game, and you'll like get some text being like, you win, right? But we're going to give it a lot of health. So you're going to be dodging this thing for a pretty good amount of time, which adds a lot of difficulty to avoiding the square, right? So one of the first things we're going to need is a floor, right? Let's kind of figure out how we want to add that. Well, I want the floor to be green. It's kind of a ground color, you know, I kind of like it. So, well, how do we make a new object and put it into the world? Well, we know to make the player, we made a player object, right? So why don't we start with something like that? We're going to say let I don't want to call it ground or floor because those are kind of like math terms as well. What's a good name for like a floor? I don't know. let's call it grass. How about that? We can touch some grass. So we're gonna make an object. Now, where do we want this object to be? Well, we want it to be at x0, so it starts at the left side of our screen. Now, y, there's a couple different ways that we could do this, right? I could either put that the y is like whatever the height is minus this other thing, you know, all this math or whatever, that's just a bunch of random numbers. So I could say like, oh, well, I know that the canvas is 600 tall. I want it to be 600 minus 50 or whatever, which is also going to be the height of the grass. Anyway, again, we're like putting random numbers here. Or we can say like canvas dot offset height, right? Because we know that's the same thing. And then minus 50, which is going to be this grass's width or height, sorry. And that's probably about as good as you can get to keep words in and numbers out, which is your like end goal. So we're going to say the width. Well, the width we want to be the whole canvas width, right? So we're going to say canvas.offset width. And then the height we said was going to be 50, right? So this should be at the left side of the screen, somewhere around here. It should start here, and it should be the width and height of like filling the rest of this. And we also want it green. So do we want to manually keep setting colors when we draw, like we're setting blue here, or do we want it kind of customizable? I think we'll make it a little bit customizable. So here I'm going to say just color, and I'll say blue, right? And the grass, I want to say color. We'll say this is green, right? So I'm going to change my playlist. Okay. So now we have this color attribute to our objects. Now I can say, well, can fill style equals, and I'll just say player.color. That way, like, all of our player stuff is kind of bundled together, right? Because we're changing the player's color, and then we're changing the player's position. So I can easily look at this and see the word player, and I know, oh, well, we're drawing stuff with the player here. Okay, well, let's draw the grass. I'm pretty sure is what we called it, right? Yeah, so the grass. We're going to say can.fillStyle equals grass.color. Can.fillRect, we're going to say grass.x, grass.y, grass.width, and grass.height. So now that we've actually added this to the rendering part of the game, we'll be able to see it. So let's refresh the page. And there we go. We see the grass. Because the grass is x0, which is here. Y, so how far from the top it is as tall as our canvas minus 50. So that's about here. And then the width is the full width, and the height is 50. So these 50s kind of like cancel each other out to where it's 50 from the bottom. Nice. So we have this ground, right? And we can still move our character around. But we can just kind of go under the grass, which is not great. We can also just go off the screen, which is not great, right? So what are we going to do about this? How are we going to solve this problem of us going past the grass and past the wall? Well, it's very similar to how we reflected the DVD bounce, right? And in a sense, we can call that a collision, is when this object touches this object, we want it to do something. That's what a collision is. Or when this touches the edge of the canvas, we can call that a collision as well. So how are we going to do collisions? We kind of did it earlier, but this is going to be like between two objects or whatever. So normally you would check if the bottom of this is greater than the top of this. That's one check. If the right side of this is greater than the left side of this, if the top of this is less than the bottom of this, and if the left of this is less than the right of this, that is like a perfect collision between two squares. So if we have multiple squares, which we will get into, we can do that logic. But to keep it really simple, because this grass is never going to move, and we know its position and everything, like we know how far down the screen it is, we can kind of cheat a little bit. We don't have to check all of the sides for collision, because we'll never touch the left side, we'll never touch the right side, and we'll never touch the bottom. We're only ever going to touch the top, right? So we're only ever going to check for that one collision. So in our update, let's kind of clean this up a little bit, okay? Let's make a new function. We're just gonna throw it like undertake. We're gonna say function. We'll just say like update controls, something like that. Something pretty just generic, because these if statements are taking up a lot of space. Let's cut them out. We'll put them in here. And then in here, we'll just say update controls. Same exact thing. We just cut some code out from here, put it down here because we don't want to look at it anymore, right? And let's even like add a bunch of space here. Like I don't want to look at anything down here anymore. So now we still have all of our code. It just looks a bit better. And we know here we're updating what controls are being pressed. So, you know, it's something generic. But we can add other things here now. And one of the things that we'll need to add is after we move the player, we need to do our collisions. Right? Because we're setting the velocity to 0, then we're kind of changing the velocities a bit. Let's actually change this to update velocity. And then we'll change the function down here to match that. Okay, that makes a bit more sense. So we're updating the velocities, and then we're actually updating the player's position. So let's kind of collapse this a little bit as well. And I usually call this like process collisions, something like that. We haven't made this yet, we will. But we need to process the collisions after we've moved the character. And that's because if we say, are these two things touching? And we say no, and then we move the character, then the character's gonna overlap the thing until we do the check again, right? But if we move the character so it's overlapping, and then we check if it's overlapping, then we can say, oh yeah, it is overlapping. Let's fix that before it's drawn to the screen, right? So then you'll never see that this overlaps this. It'll all be behind the scenes. So let's make another function. We'll just do it here for now. We'll probably move it later. Process collisions, okay? Now, we talked about this side being greater than this side. So how do we do that? Well, in order to get the height of this, it's the y of this plus its height, right? So we're going to say, okay, well, if player.y plus player.height, okay, so that gives us the height of this like depth right here. If that is greater than, and we can try equals might offset it by like a pixel. We'll kind of figure it out as we go. If that is greater than or further down than this, well, to get this, it's just the y of the grass, isn't it? So we just need to say grass.y. Okay. So now we have a way of knowing if the bottom of this is greater than the top of this, or if they're like colliding as far as we care, right? So if we do this, what do we want to happen? Well, we want the player to stop, right? And there's a couple different ways that you can do this. You can either say I want the player's y to subtract whatever the player's current y velocity is. Because we just added the y velocity to get into it. So if we subtract the y velocity, it's going to be back out of it, right? But something you'll kind of notice with this is if I go down, it does keep me from touching the bottom. Like I'm still holding S right now to go down. It stops me from going into the grass, but I'm not like touching the top of the grass, right? I'm kind of hovering there. And no matter how much I try to touch the grass, I never will visually touch the grass. And the reason for this is because we're jumping. Where is it? Where's the player? No, not the player. Uh-oh, it's part of the logic we hid away. So we're jumping 5 pixels every time we move, right? Well, there can be 4 pixels here that are completely unaccounted for. So we try to jump 5 pixels, and then we jump back 5 pixels. That still leaves these 4 pixels here, which is really infuriating. And like, you know, what are we gonna do about these 4 pixels? One thing you can do, it's kind of computer intensive, a little processor intensive, is instead of just subtracting whatever y velocity they just did, we could do a for loop, and we could slowly subtract from 5 until it wouldn't collide anymore. So we could say we're moving 5, it touches, and then we want to slowly skirt it back until it's not touching anymore. So that is like a perfect collision, but it can be kind of processor intensive, like I said, because if you're jumping, let's say, 50 pixels instead of just 5, that means that for loop could go 49 times before it finds a solution to the collision. And like that's a lot when you're doing collisions for everything that's on your screen. Like that means you're doing like 50 loops for like 50 different things on the screen for everything that it could possibly collide with. Like it's a lot of processing that your computer has to do. And we don't want to put our computer through that. That's going to lower frame rate. That's going to like, you know, it's just not going to be good. So what can we do instead that can kind of cheat this a little bit? Well, we can say, specifically with this game, there's other solutions that are more complicated if you're going to do like a platformer or something, like a, you know, if you're like running to the right and you're jumping platforms or something, like we can't do this kind of collision fix with it. You would probably need to do a perfect collision system. But in this instance, we can just say, why don't we just say, if you're touching, just move it so the character is just above the grass, right? Like, we don't need to do perfect loops, whatever. We just need it to be above the grass. So instead of subtracting the player's y from the y velocity from the player's y or whatever, why don't we just say the player's y position is the grass's y position, and then we're going to have to subtract the player's height from that because the player's y position is here, so we need to say it's here, and then we also need to lower it by the height so it will be sitting on top, right? So if we refresh now and we go and touch the grass, boom, we are perfectly touching that grass. Perfectly touching that grass, right? We can even skirt along the grass now, but I can still fly. which isn't part of our game design, right? We said there was going to be gravity and that you could jump, right? So we don't want to fly. We want to fall until we touch the grass and then stop. And when we push the jump button, then we'll jump and then we'll come back down and touch the grass again, right? So we need to kind of change a little bit about how the player moves, and we need to add another force to our Y velocity. So we'll go into it. We'll kind of take some small steps. I'm gonna take a little drink first. Okay. So what is the most important thing that we need to add right now? And it's easy to say like gravity, but like what is gravity, right? Gravity is a force that constantly pulls you down to earth, right? And to do that, let's say gravity has like a frame rate. It does it applies this force every frame of your game to keep pulling you down to earth, right? So we actually have that in reality. It's called like the gravitational constant or something like that, but that's some physics that you probably ignored through high school. So we're gonna kind of fake that. We're gonna say after we set your velocity to 0, we're gonna keep in mind what you want to do here, and then we're gonna also do some gravity stuff. So we'll say like gravity, and we'll say that the player Y velocity, right? We're gonna add to it. No matter what buttons you're pushing, I don't care. I'm going to make it so you're moving down the screen, right? That's kind of how we're gonna emulate gravity. And we're gonna say, like, no matter what, you're going down 7, right? So if I refresh, oh my gosh, I'm not pushing anything, but I'm falling. What? And if I push up, I don't actually go anywhere. And the reason I don't go anywhere is because I'm being pulled down faster than I can possibly move up, because we can only move up 5, right? But if I said, you know what, let's move up 10 instead of 5, and I refresh, now we can move up just enough to fight back against gravity, and when I let go, we're gonna fall back down again, right? So as long as I'm holding the button up, we're slowly resisting the gravity. Well, that's kind of what we want, but it's not really smooth. It doesn't really feel like gravity. So we're gonna do this a little bit differently. And we're actually never going to move up. We're gonna make something that's a jump. And so we can actually delete this completely. We're never moving up. We're going to jump, which is a different thing. And then instead of just adding 7, we are going to we want to add like an acceleration to the gravity as well. So the longer you're in the air, the faster that gravity is going to pull you down. So it's not constantly pulling you by 6. I want it to pull you by 6, then pull you by 7, then pull you by 10, then pull you by 20. Like, I want it to escalate. So you're constantly moving down the screen faster until you hit the ground. at which point I don't want you falling anymore, because you're not falling, you're standing, right? So let's see if we can try to kind of show this. Let's make a variable. We'll call it gravity. We'll set it to 0 to begin with. And then every loop that we do, let's increase gravity. So similar to what we did before, we're going to say gravity plus equals 1. But we're not going to reset gravity the way that we're resetting the player's velocity, right? Because gravity is a velocity, it's not a constant. So now that we're increasing gravity, we need to say player dot yvel plus equals gravity, right? So this is gonna slowly make us go faster and faster down. Like you see, when we first start it, we kind of fall a little bit and then we fall really fast, right? So we kind of have what we're going for here. Let's slow that down a little bit. Let's say like 0.5, right? So now it kind of hangs a little bit more before we like fully drop. I want it a little bit stronger than that. Let's try like 0.8. Okay, that's kind of what we're going for. Let's try like a 7, maybe like a 7.5 even. Okay, that's kind of what I'm going for. I'm kind of feeling that, you know? But the problem right now is if I look at gravity, we're at over 300 now, but we're touching the ground. We shouldn't have any gravity right now, right? So we need to say when we touch the grass, we don't want gravity anymore. Well, we touch grass here, right? So here I say when I touch the grass, like quote unquote, we can even comment this so we know we're touching the grass. I want to say gravity is 0 again. So we're going to start at 0. We're going to increase it until we touch the grass. And when we touch the grass, it's going to be 0 again. When we refresh, I fall, I touch the grass, and when I check gravity, it's at 0 again. Now, that's cool. We can move around. We're not being pulled down anymore. Like technically we're being pulled down, we're touching the grass, we're resetting it to 0, we're getting pulled down, we're touching the grass, we're resetting it to 0 over and over and over again. But this is kind of how you like emulate gravity, and like visually it looks like gravity, right? Like we're falling, we're touching, and then we're stopping, right? So that's a very like simple gravity. And now we need to be able to jump. Now, how are we gonna jump, right? Well, because we have gravity, it allows us to play with our velocity a little bit. So instead of moving up, we want to adjust our velocity to be something like higher than what gravity is pulling us. And right now it's 0. So we'll go up like pretty far if we go really high. So let us let's think about it for a second. So instead of up, not ump, we'll say jump. And that's false. So we haven't jumped yet, right? Let's even say like can jump. How about that? That's more of a Boolean sort of thing. And these, we should probably say like is down, is left, whatever. It's fine. Let's think about it for a minute. So when we when we press the jump button, which is going to be our W, you could do like spacebar or something instead, but I'm going to do W. So we want to say if player dot actually let's do jump. So if the player is jumping, we want to say player dot yvel, and we're going to subtract something kind of absurd, right? Let's do like 10 to begin with. And we said this is jump, and we need to adjust our keys that we're pressing to match that. So instead of player dot up, we want player dot jump and player dot jump, right? So now we've like fixed our button presses. So now when we push up, we're going to jump instead of move up. And that's just kind of a variable renaming thing. We haven't really changed anything as far as how the keys work. But how? Like, we're saying we're jumping, and so jump is true when we push up. And we said down here that to jump, we're going to subtract 10 from our velocity. Let's take a look at it, right? So we fall down, our gravity hits 0, we push up, and we're actually doing like a little hop, aren't we? And the more I hold up, the more I'm gonna keep jumping. But why is it working, right? And how come when I just tap jump, we do like a short hop, but if I hold jump, we do like a full hop? And this may be how things like Super Smash Brothers works. That's why you can like tap and do a short hop, or you can like hold it and do a bigger jump. And we can make the jump bigger by doing something like this and just making this number bigger. So we push up and it like, we can full jump, or we can like short hop or whatever, right? But us going up is like, it's very straightforward, isn't it? It's not like falling back down where we like have gravity, sort of. It's just very sudden. If I'm being honest, I am a little rusty and having a hard time remembering how to change that. But we need an is jumping toggle. I know that much. So we're gonna say underneath yvel, we're gonna say is jumping. We're gonna say false because we're not jumping yet, right? So when we push up, we want to say if player dot is jumping. If we're already jumping, we don't want to jump again, right? So if we're not jumping, then let's jump. So similar thing, we're just gonna say like minus equals 20, right? So if we're not jumping, we want to jump. Well, in order to jump, we have to say is jumping is true now, because we are jumping. And so we're gonna jump, and the next time it checks if we have the jump button down, it's gonna say, well, we're already jumping, so don't jump again, right? Let's try that out. We push W, and now I only hopped once, and it was very short, right? It's very short hop. So what if we say this is like 200 or something? Okay, we like teleport up, we fall down, and then we can't jump anymore. Well, let's fix the not jumping thing anymore. We want to be able to jump again when we touch the grass, right? Well, where do we touch the grass? In our collision, right? So the same way we're saying gravity is 0, we need to say is jumping is false. Because if we're touching the ground, we're obviously not jumping, right? And we might need to reorder this a bit. We'll find out. Let's refresh. Okay. I jumped, I fell, and now I can't jump again. So that's because it's player is jumping. My bad. So we jump, and we can keep jumping so long as we touch the grass, but we're still just teleporting up, right? That's not what we're going for, right? So how do we fix that? Like, the falling part looks okay, but the jumping part is like ridiculous. Let me think about it for a second, because like I said, I haven't done this in a while. But we're on the right path, right? Now we can't like jump on top of our jump, kind of like a double jump. We don't have short hops and long hops. We just have a hop, right? So we're getting there. I believe I just remembered how it works. So we have gravity, which is constantly pulling us down, right? And we saw that if we inverse gravity for a second, then we'll go up. And then because we're constantly subtracting or like pulling the character down, eventually we'll come back down, right? So I think instead of adjusting the player's velocity, what if we play with gravity a little bit? So what if we say gravity, and we'll set it to 20 or something to play around, right? So we're setting gravity to 20, which should pull us up. But because we're not touching the grass, gravity should, this should be -20, my bad. So because gravity is pulling us back down, it should be slowly increasing it every frame, right? Because that's what we told it to, is we're constantly increasing gravity. So if we have -20, suddenly out of nowhere, we will jump up 20 pixels, then we'll jump up like 19 pixels, then like 18 pixels, then like 15 pixels. So slowly we're going up a little bit less, right? And then eventually it's going to hit 0 and it's going to flip and it's going to start pulling us back down, right? So let's take a look at this. Let's refresh. I'm going to jump. Hey! That looks kind of like a jump, doesn't it? Let's do it again. Oh! That looks pretty smooth, doesn't it? Because now we're constantly adjusting a velocity and we have this like linear arc, right? So we have this like smooth jump. Well, I can keep jumping so long as I touch the grass first. So this is really pretty good, right? It looks pretty good. I want it a little bit higher jump for what we're going for. Let's try like 30. Let's try and jump. Whoa, that's a bit too much. That goes like off the screen. Let's try like 25 or something. Okay, we're getting there. I think maybe like a little bit higher. We want to be able to get close to the top of the screen for this game. So we just need to play with numbers until... Okay. Let's try like 26. I don't want to get too high, give the player too much wiggle room for what we're doing. Okay, that's a pretty decent jump. We can like almost touch the top, and then we fall down until we touch the grass, and we can only jump if we've touched the grass. So I'd say that's a pretty good implementation of gravity and jumping, right? But we're not moving left and right very fast. It doesn't feel very smooth to play. Let's adjust how fast we're going left and right. And in order, and we're never going to go down either, I should say. So let's just remove that altogether. We're not going to increase your ability to fall back down to earth. So let's completely remove that from the game. Down is S. So we are not going to listen for S anymore. We don't need it. And then our up key is our jump button. So we're not moving up either. We're jumping, which is like reversing gravity, right? Okay. So I said we want to move left and right a bit faster. Down here, we have 5, just kind of randomly. Let's change some of these numbers. Let's add them to player so we don't have to keep coming back down there. We'll say like jump velocity, something like that. I think we put that at like 26, didn't we? Yeah, so negative 26. And then we'll say we'll just call it velocity. Nah, let's call it speed, because it's like the speed you're moving, right? And we'll set that to like 7 instead of 5. It'll be a bit faster. So instead of 5, we're gonna say player speed, and here was player dot jump velocity is what we called it. Okay, now we're never gonna have to touch this again. I'm never gonna have to come back and update the player's velocity. We might... No, I don't think we'll even have to do it for the enemy, because the enemy won't have the same kind of movement we do. So I think we're pretty much done with this function altogether. So finally, we can just like take it off the screen. If we want to move left and right, faster or slower, we can adjust it in player, changing speed. If we want to jump higher or lower, we can change the jump velocity in player. So I think we pretty much have all of the movement customizable just by changing the variables here now. So that's pretty cool. What is the next thing that we were going to work on? And I'm going to move gravity because it's kind of more of like a global thing. I kind of want to put it towards the top, maybe after our key listeners though. And yeah, so now we have like objects and globals and functions all in like their own sections. So, well, we talked about shooting bullets, didn't we? Because we need to be able to shoot the enemy, right? How are we going to do that? Well, we need to be able to shoot bullets. So we need there to be an object called a bullet for us to shoot, right? But we don't just want one, like we have one player or one grass. We want to be able to shoot multiple bullets, and they all need to have their own properties, right? So how do we make it so we can make multiple objects that have their own properties that we can access like this? So one thing you could do is you could make like a class called like bullet, And then you can have like a constructor in this class and all this stuff. I don't think we need to really control this all that like fine tune. So what we're gonna do is we're just gonna make a base constructor and we'll call it bullet. It's gonna take an X, it's gonna take a Y. I think all of our bullets are probably gonna be the same size, right? So we don't really need to give it a width and height. Like dynamically. We just kind of need to change where it's positioned. So we'll just do this. And then we'll say this dot x equals x and this dot y equals y. So this is a bit more of an object-oriented thing if you want to learn more about object-oriented stuff. This is essentially a constructor for a bullet object, and we're saying that the bullet's x value is whatever we put here, and the y value is whatever we put into it as well. And I'm pretty sure this is how you write it. It might be a bit different. We'll have to figure it out. But we're just gonna say this dot x is 5, or not x, this dot width is always gonna be 5, and this dot height is always gonna be 5. So it's a relatively small bullet, considering we are 50 pixels tall and wide. This is only 5 pixels tall and wide, right? So overall, pretty small bullet, but there's gonna be a lot of them. So we don't want to like clump the screen up, right? With just 1,000 bullets going everywhere. Now, how do we make a bullet? Well, we need some way to be able to make the bullet. So we're gonna actually... I feel like I keep saying we're never gonna touch this thing again, and then I go back to it. So we need to be able to push a button in order to fire the bullet. I want to make that button the space bar, and I think spacebar is 32. We can just log it out again. So let's just console log e. Let's figure it out. Let's push the spacebar. It is 32. I was right. Let's go. So I want a listener for if we're pushing 32, which is spacebar. And instead of moving the player, I want to shoot bullets, right? Well, we know that we need to add toggles to player if the player's doing something. So let's think about that for a second, and we'll say the player, we'll say the player is shooting, something like that, right? And this should probably be up with the other things, maybe. I probably should have named these something else. It's a little confusing with these being here too, but like this is like movement buttons being pressed, and this is like an action is being taken. So anyway. And then I don't want to constantly be shooting either, but I think we'll show that first. So here we're gonna say player.isShooting is true. So while I'm holding down the space bar, we're shooting. Well, when we let go of the space bar, we're gonna not be shooting anymore, right? Okay, so we've kind of added all the toggle stuff for the buttons. Now we actually need to do something in our update. How about we say, Let's make a new function somewhere. Let's do it before collisions, because the bullets are gonna have collisions themselves. Let's do it before velocity and everything too. Let's just put it up here, right? Let's say shoot bullets. How about that? And then we'll put that here. Shoot bullets. So we're gonna do this every loop of the game. And in order to shoot a bullet, we need to make a new bullet. We need it to exist, right? So let's say let new bullet equal a new bullet. And then this, let's just say it's at like X is 5, Y is 5 for now. Let's not get too complicated with it. But we only want to shoot bullets if player is shooting, right? Because if we're not shooting, we don't want to make new bullets. Okay, so if I refresh, now there's nothing. If I push spacebar, nothing happened. That's because we're not drawing the bullets. Okay. So technically, as far as our game logic goes, there is a bullet right here. We just can't see it because we're not drawing it. So we need a way to dynamically create these bullets like we are right now, but also to be able to manage them so we can, like, let's say loop through them so that we can draw them all, right? So how do we want to do that? One way that's pretty decent is we can make an array. And so we're going to make an array. We'll put it below gravity. And we'll say bullets is what we'll call it. And we'll just make an array. So now we have a wider scope array outside of this function that's going to manage all of the bullets that have been shot since the beginning of the game, right? And here we can say, all right, well, let's add what's it called in JavaScript? Is it pushback? Is it push? I think it's push. We're gonna say bullets dot push new bullet, right? Because this is gonna add this new bullet we made to this bullets array. And then in order to draw all of the bullets, let's do it above everything else. We'll say bullets. And we need to make a loop here. We're going to say for, I think we can say like bullet in bullets or something like that now, can't we? Let's look for in Japanese or Japanese JavaScript loop. Let's look at this. Yeah. So we say this local variable in this array, and it'll loop through everything that's in that array. So that's exactly what we're looking for. So for every bullet that's in our bullets array, we want to do this thing. So we're going to do, before we draw it, let's change the color first. Let's say the fill style is what's a good bullet color? Let's try like brown, something like that, right? So now we're drawing in the brown color. Let's fill a rectangle that is the bullets X, the bullets Y, the bullets width, and the bullets height. Okay. I think we're getting somewhere. Let's refresh. I pushed the space bar and nothing happened, which is awesome. So why is nothing happening? Well, let's look at bullets. We obviously have a bunch of bullets, right? And they have an XY width and height. Okay. So why are we not drawing them? That's the question. Or maybe we are drawing them, but they're just really small. Let's think about it while I go to the bathroom. So I will be back. Okay. So I didn't think about it at all. Let's think about this, right? Like maybe brown isn't a color. Let's try blue again, and then we'll try it again. Okay, that doesn't seem to be the problem, but let's leave it at blue for now. And let's maybe log the bullet instead. Let's see exactly what we're looking at. So it appears to not be looping through our bullet array. Why would it not be doing that is the question. Is it because this loop is not working? Because we know bullets is... Oh, there are no bullets. Give me a second. Let's refresh. Okay, we made a bunch of bullets. Now it's telling us all the bullets. So it is looping through. So we know it's looping through. Why is it not drawing the bullet? So we're filling a rect at X, Y, width, and height. If we look at bullets, we don't have any right now. We need to refresh this. So now we have bullets. Let's check out the bullets. X, Y, width, height. X would be 5, Y would be 5, width would be 5, and height would be 5. Is it just really small? It could be, but I don't think so. Width, height, X, Y. I'm sure I've just like spelled something wrong or something, right? Let's try brown. Let's try and make it bigger. Let's make it like 50-50. That doesn't appear to have changed anything. Let's set it back to 5. We've reached our first bug. And this is where the exciting part of programming happens. Where you don't accomplish anything for a little while you figure out what's going on. So we are drawing the bullets. We're doing it after we've done the other stuff. X, Y with height. X, Y with height. X, Y with height. We're shooting the bullets here, which is adding the bullets to the array, which, by the way, we can make this shorter. It's the same thing, but we can make it shorter by doing that, so we don't have to make a new variable. So the player is shooting. If the player is shooting, which they should be shooting if the key is down, which is adding it to the array. And then we have the array, but it's not drawing the bullets. This is strange. Not sure how exactly I want to debug this either. Let's change the fill style. We're filling the rectangle. XY with height. Let's just try doing like random numbers in here. So for every bullet, we're just gonna do random things, and it draws it now. Isn't that interesting? So it's something with accessing the values of the bullets. So maybe the way we made our constructor isn't good for the bullets. Let's Google JavaScript constructor function. Okay, that looks the same to what we have, doesn't it? Adding a shared method to the prototype for memory efficiency. I don't really care about that. We create new instances using the new keyword. What appears to be the problem? Let's say console log bullet.x and copy this for each one. See if there's some sort of misunderstanding here. And we can just comment this out for now, so it won't draw them, but it'll give us information about them. And just to know it's the beginning of a bullet, we will say bullet. Okay. So per space, undefined. So it's not accessing the values of the bullets. Which if we say bullets, we need to get these out of here. Okay. If I say bullets, we know that there's bullets. And that they have values. Maybe it's really strange. I feel like maybe we're not getting it casted to like a bullet object or something. But like for instance, if I log the bullet itself, right? Then it's just giving me a number. Isn't that interesting? So how we're looping through the bullets is probably not good. So if I say for in array of objects JavaScript, what does Google tell us? Tells us to do, and this is not what we wanted, I don't think. You can do a for each instead. This is how I'd normally do it, but that can introduce some issues later. It's basically telling us not to use for in this instance. So I'll tell you what, we'll do bullets dot for each, and then we will do an arrow function. So an arrow function is kind of like a lambda, if you've ever heard of that. But basically for every object that's in our bullets array, we're gonna do something with it. And I'm actually gonna call this bullet, so we know we're doing it for each bullet that's in the object. And here, if I say log bullet, now we're getting bullets instead of numbers. So this is working a lot better. So we're gonna do it this way. So can fill rect bullet.x, bullet.y, bullet.width, and bullet.height. So now, when I push spacebar, a bullet appears. And it's actually multiple bullets, because if we look at our bullets list, there's tons of bullets. There's 48 of them right now. but they're all drawn on the same spot, so it just looks like one bullet. But it's working now. Problem solved, bug resolved. You know, we're chilling. So we've made bullets, but they're here instead of like coming out of our character or something, and they're not moving, right? So now we gotta think about what we're gonna do with that. And in order to do that, I think we should give the bullets a velocity similar to our player, right? But I also, like, there's a couple other things we're gonna have to play around with, but let's just do this for now. Let's give it an X velocity, and we'll say it's like 7, right? It'll move the same speed we are. We might increase this later, but for now it's fine. And then in our update, we're updating velocities here, right? So what if, well, no. Right? Yeah, I guess this works. It should really be like update position or something instead. Because we're not updating velocities per se. We're more updating the positions due to the velocities. So let's change that. Okay, so now we can update where the bullets are to in here, which is where? Update position. So we're going to update our movement, but we're also going to update the bullets movement. So we're going to say bullets for each bullet. We're going to say bullet dot x plus equals bullet dot xvel, which I think I named wrong in the bullet. No, I didn't. Okay. All right. So now when we refresh and we fire bullets, they're firing across the screen, right? They're moving. So that's good. That's good. That's good. Now we need to move where they start. So instead of 5, 5, we want to be basically the center of the player is where we want to make the bullet, right? So that would be player dot y plus player dot height. But wait a minute. If we do the y plus the height, then it's going to start down here, right? We want it like about halfway up our character. So we actually want about half of the character's height, right? Because we'll go here and then we'll go about halfway through the height. It'll put us about here. And that's for the Y position. So let's make another one for the X positions. Player.x plus player.width. And then again, about halfway through the width. Not really the whole width, right? So we'll do divided by 2 and we'll see how that looks. So now when I fire, it seems to come out of the character, right? That seems pretty chill. And let's see. It's starting a little to the right. I think that's because the bullet is actually moving and then being drawn before we originally see it. So the first like existence of the bullet would be here, but it's moving and then drawing. So it looks like it's starting here, which is honestly fine. I'm not really concerned about that. But we're making a bunch of bullets, right? And if we look at our bullets array, we have 1,650 of them. Even though they're not on the screen, we're still managing them in memory, right? So that's not very good. what are we gonna do about that? So there's a couple different things you can do. One is you can handle collisions and say if the bullet essentially is off of the screen, then you can destroy the bullet, or you can give the bullet a lifespan. So every frame you'll lower the lifespan by 1, and when it hits 0 or lower, then you can kill the bullet, right? And killing the bullet essentially means taking it out of this array. Because when you take it out of this array, it's not going to exist anymore. There's going to be no reference to it, and the garbage collector will take care of the memory for you. So, what way do we want to do it? I think we'll probably give it a lifespan. I think that's probably pretty decent. So we will say in bullets, we'll say this dot life equals, we'll try like 10, right? It's not gonna live for very long. And then every update, we're gonna shoot the bullets, and then we're also, let's just manage a lot of the bullet logic in here, I guess. So let's say process bullets. How about that? Instead of just shooting them, we're gonna do whatever needs to be done with the bullets. So we're gonna say bullets dot for each. We're gonna say bullet bullet dot life minus equals 1. So every frame, every bullet is gonna lose 1 life. And then we're gonna say if the bullet dot life is less than or equal to 0, then we need to remove it from this array. Now there's a handful of ways you can do that, but I'm gonna say remove object from array JavaScript. So we can filter, we can splice, if we're using indexes, we can splice. There's delete, generally discouraged for arrays because it leaves undefined. We can remove the first one in existence. Oh, maybe we'll do that actually. That is another way to manage it. Let's do it that way. That's probably better. So instead of giving the bullets a life, what we're gonna do is we're gonna limit how many bullets can exist. So instead of life, we're gonna say add bullets that you're shooting, right? But if bullets.length is greater than, we'll say if you have more than 50 bullets loaded in memory, right? Then we're just gonna get rid of the first one that you shot. So we're gonna say bullets.pop, I believe. Is that what that was saying? Google pop JavaScript array. It removes the last element from an array. So we don't want that. We want the opposite. We want opposite of pop, which I believe is shift. Yes, so we're gonna shift the array. And when we do that, it will remove the first one that we've made. But we want to do that when we make our 50th. or our 51st, I should say. So when we make a new bullet, it's going to say, do we have more than 50 bullets? If we do have more than 50 bullets, we'll delete one. So then we'll only have 50 bullets. And we're specifically shifting, so the oldest bullet that we've made is going to be killed. So at maximum, we will be managing 50 bullets. Now, eventually, this could cause issues as well. But we're not gonna worry about that for this small game. Because eventually the X and Y of the bullets that do exist, if you're not firing new bullets, will get so large that it's going to take a large amount of memory. But it's going to take a long time for it to like really affect the game, and you're probably going to consistently be firing or you're going to lose the game. So I don't think it's going to be a problem. So yeah, we're not going to worry about that. But now, if we keep firing, eventually we stop firing, right? And there's some weird stuff going on because we're making new bullets. And like we said, the oldest bullet, which would be the length, is going to die first after we hit 50, right? So there's always 50 bullets so long as I keep shooting, but the last one is going to keep disappearing, so we get this kind of effect, right? And this is cool. You can do a lot of different things like this, and you can make like sine waves and things depending on how you set up gravity. But yeah, so obviously if we're tucked in the corner here, we can shoot more bullets than this, right? We want to be able to reach the edge of the screen. So we can either say, well, like if we shoot 100 bullets and we'll fire, and that'll allow us to shoot longer, right? Or we can limit the rate at which the player can fire bullets. Because if you can only create a bullet a second, then we're not going to create 50 bullets before the 50th bullet goes off the screen because of its velocity. So how do we want to do this? Another thing you can do is you can increase the velocity of the bullets, which I think we're gonna do. So the bullet X velocity, we'll set it to like 11, and we'll see how that does. Yeah, so now we're shooting off the screen, right? Let's try lowering the bullet limit to 50 again. That does not reach the edge of the screen. So let's do 100. So no matter what, if we're shooting, the last bullet will be off screen before it's deleted, right? And the reason this kind of spreads out or gets closer is because we're creating them closer together as we're moving right, or we're creating them further apart as we move left. Like this is how bullets literally work. Like this is correct physics that we're looking at. It just looks strange. But yeah, this is correct. So if we're like jumping around shooting, this is kind of what it would look like. So I think we might up the player's speed just a little bit. Maybe like 1 notch. This doesn't feel like it's really flowing the way I wanted. Okay. That feels a bit better. Okay, so now we can shoot bullets, right? And this is like the main standard form of like, if you were doing those top-down games where you're a ship and like enemies are coming from the right and you're shooting, like we already implemented the bullets here, right? And then instead of just jumping with gravity, you just remove that and you go back to what we originally had, where you have like static up and down, right? So that would allow you to make like one of those shooting games, and that's pretty cool. But for this game, we want to shoot both directions. But because of a certain thing that's going to be going on, I don't want to worry about that at the moment. We'll just kind of leave shooting how it is, and we're going to move on. So what is one of the like third things that I said was going to be in this game? Well, I said there was going to be an enemy, right? And we have not done that yet. So let's make an enemy. And we'll just make it here. There's only going to be one. So let's think about this. Let's say the enemy, we're going to say its x is 0 and its y is 0. And it's gonna have some default velocities. We're gonna say xvel is like 7 maybe, and we'll say its yvel is like 7. Okay. For the enemy, we're kind of recreating the DVD bounce effect, is the idea of how the enemy is gonna move. And when we restart the game, I broke something, because of course I did. I didn't do an equal sign. Okay. So when we start the game, our player is starting in the top left. Which, if the enemy's starting in the top left and you die by touching the enemy, we should probably change that. So let's change the default values of the player. Let's try and put them in the center of the screen. So we can say canvas dot offset width, and then we're going to divide it by 2, because that'd be the center of the canvas, right? But that's the left side of our character that would be there. So we also need to shift it by about half of the character's width, right? So let's subtract half of our width, which is 25. We have to manually put 25. We can't say player width, because the player's width hasn't been defined yet, which is a little unfortunate. But, you know, at least they're all kind of clumped together, so it's easy to jump around and see what values are what. And then for Y, I kind of want to start on the ground, you know? Like, technically, when we start this game, if I push up immediately, we jump while we're in the air, because our default value is that we can jump. We haven't jumped yet, because our is jumping is false, right? I could set this to true, have us fall to the ground, and then we could jump. You know, there's a couple different things I could do. It doesn't really matter. If I start us on the ground, then us jumping immediately won't be a problem, right? So let's say we want it to be the grass's height minus the player's height, right? And the grass's height is this. So let's get that. And then we need to get rid of the player's height, which is 50 as well. And I believe that should put us in the middle, where I wanted us to be. So now when we start the game in the center of the screen, on top of the grass, and we can jump and move, right? So before we jump right into the enemy thing, we already kind of made the enemy, but we haven't drawn it or given it like width or height or anything yet. I want to make sure we can't run off the screen, because if you can run off the screen and the enemy's on the screen and bound to the screen, then you can just live forever, can't you? And we don't want that. So let's add a bit of the bounce logic here, kind of similar to the ground. We're going to go to our collisions, and we're going to say if player.x is less than 0, then player.x is 0. Okay, that's a very standard bound that we can make. And then if player.x plus player.height is greater than our canvas width, so offset width, then player.x is canvas.offset width, and then we're going to have to subtract the player width from that. So this should bound us on the left side. This should bound us on the right side. Let's check it out. Okay, can't run off left. Okay, I can't run off right. So we're bound to this map now. We can't go down because the ground's there. We can't go right because that's the edge of the screen. We can't go left because it's the edge of the screen. And we can't go off the top because we can't jump that high. So now we're limited to our play space. We can't leave, right? And that's exactly what I want, because I want you trapped in with the enemy as it's bouncing around. So let's go back to the enemy now. We have an X and Y. Let's give it a width and a height. And the width, let's say it's something big. Let's make it like 300 by 300 or something, right? And let's draw this bad boy to the screen. So let's draw it. We'll draw it last. I don't think that'll be a problem. So we'll say enemy, and we're gonna fill rect, enemy X, enemy Y, enemy width, enemy height. Okay. And let's make it so the enemy is red, because red is like pretty default enemy color, right? Refresh. Boom. That's a massive enemy. Okay. Let's maybe cut it down a little bit, because if this thing is bouncing around, that's gonna be really hard to avoid. So let's try 200. That seems a bit more reasonable. So I think we will go with 200 for now. So the enemy's not doing anything. Let's make it do something. So we need to update the position of the enemy, similar to how we were updating our position, right? And then this is like screen bounds, and we will do this is collisions. I'm looking for velocities, which of course is one of the things I said I was not going to touch again. So this is for the bullets. This is for the player. And then we're going to process the enemy's position, right? So enemy dot x plus equals enemy dot vel x. Enemy dot y plus equals enemy dot y vel. I wrote it wrong. X vel and y vel, not vel x or vel y. Okay, and it's x vel and y vel are 7. So it's gonna choo, and then it goes off the screen, right? So it starts here. It's gonna go x7, y7. So it's just coasting down like that, right? So we want it to bounce now, right? So let's go to our collisions. It's going to have very similar side collisions to the player. Let's say player screen bounds or something like that. So let's do enemy collisions. So if enemy.x is less than 0, right, then enemy.xvel is negative enemy.xvel. I have hiccups. And that's going to flip it around if it touches the left side, right? So we're going to do the same thing on the right side. So let's say or enemy x plus enemy width is greater than canvas.offset width, right? So if it touches the left side or it touches the right side, we're going to invert its x velocity. This is the same thing that we did at the beginning when we made the DVD bounce thing. Now for the top, you want to say if enemy dot y is less than 0, then enemy dot yvel is negative enemy yvel. So we're going to invert it again. We didn't need this constraint on the player because the player can't jump that high, but we will need it for the enemy. If it's like bouncing up this way, then it will bounce back down, right? Now, the bounce on the bottom we haven't done yet. And the reason we haven't done it yet is because we don't want it to bounce off of the bottom of the canvas, right? We want to bounce it off of the grass, which there's a couple different ways you could do it. You could specifically say the grass is Y position, or you could just raw code it if you don't want the two objects tied together like that. I think I'm going to tie them together. I'm not going to do much with this game when we're done with it, so I think whatever I write will be fine. I'm not going to be updating it all that much or anything. So I'm just going to say if enemy.y plus enemy.height is greater than, we called it grass.y, then we're also going to invert it. So we're going to cut this and we're going to add it to this section because that's the vertical checks that we're doing. And let's try that out. Okay, it appears to bounce, but it does seem to kind of clip with the grass a little bit. And the reason for that is because it is being drawn after the grass, so it's on top of the grass. And then another thing is it might be because of this as well. Okay, but now it doesn't seem to exactly touch. Like, it doesn't visually look like it touches. So let's leave it like this, but let's draw the grass last. So let's take the grass here and we'll draw it after the enemy. And that will kind of hide that clipping effect we were seeing. So now it looks like it touches the grass and then bounces, which is a lot better. Now, the enemy appears to be bouncing in the center a lot. We don't want it to be like central to the center of the map, right? So what if we adjust some of its values? Let's make it so the x velocity of the enemy, let's make that a bit lower. What's that gonna look like? Okay. It's more of an up and down sort of pattern like that. I feel like the y velocity is a little high as well for what I'm going for. Let's try this. So we're back to kind of I don't know. It looks like somewhat random, right? If I was trying to avoid touching this, I feel like I could. It might be a little bit difficult, which is kind of the point. So let's leave it like that for now. I think that's pretty decent, right? So basically we're going to be shooting the enemy like this and running back and forth. Now, you might see the problem with us shooting bullets that I was talking about earlier. We can shoot it perfectly fine, but if we're on the right side of it, we're not shooting anymore, right? Like we're just shooting off the screen. And that's not very good, right? So now that we have the enemy, we can do things in relation to what the enemy's values are. So instead of just creating a bullet that has a velocity of 11, right? We're going to say, we need a variable. Let's say like right is right, something like this. So like, is the enemy on the right side of us, kind of. And I might be overthinking this a little bit. Let's just we'll say x velocity here. Okay, and we'll just this xvel is xvel. So remember that it was 11 though. So then in process bullets, when we shoot the bullet, we do need to do an if statement. And we need to break this out of this push and have it be its own thing again. So we'll say new bullet like this. Okay, so if now we're gonna check the enemy's position in relation to us, right? If the enemy is on our left, we want to shoot left. If the enemy is on our right, we want to shoot right. But we don't want to manage like which way the player is facing. We don't have a sprite or anything, so it's kind of hard to tell. So why don't we just make it so it automatically shoots towards the enemy? We don't have to specifically be facing the enemy, right? So we want to say if you can do either the player first or the enemy first. It kind of changes the greater than, less than, whatever logic. But let's say if player.x plus player.width divided by 2. Okay, so this is our x position plus half of our width. So that's the middle of our character, right? If it is greater than the enemy's x position plus the enemy's width divided by 2. So the x position plus half of the enemy is about half the enemy, right? If we are greater than its y position, it means it's on our left, right? So then we'll say, I want to make a new bullet that is with the velocity of -11. We want it to be going left. But if we are not on the right side of the enemy, then let's make a bullet that goes to the right, right? And I guess an easy way to do this is we will just push these new bullets, right? So you're still only making one bullet no matter what, because you either make this bullet or you make this bullet. So we don't have a bullet count issue of making more than we're deleting. And yeah, like if we're setting the bullet's velocity to 11 or negative 11, which we can still actually keep in the bullet thing. Let's say like the default xvel, right? And we'll say this is 11. And then instead of this, we'll say, actually, can we do that? I don't think we can do that. Never mind. Back it up. So yeah, we're creating a bullet with either positive or negative velocity, depending on where we are in relation to the enemy. So let's refresh. So I'm firing bullets. They're going to the right. I go to the right side. Now they're going to the left. So no matter what, we'll be shooting at the enemy, right? And this is the kind of effect that I wanted to go for. Now, our bullets aren't doing anything. And if we touch the enemy, nothing happens, right? This is, we've got a little bit more to implement before, before we're done with the game. So as you can see, like even simple games are likely going to take you several hours, if not days or maybe a couple weeks, depending on how much you want to put in the game, right? If I was doing graphics and audio and all this stuff, and I had like a world I was building with like multiple characters and all that stuff, I'd expect it to take you a couple weeks, if not like a month or two, and probably some friends that are helping you with that as well. But all in all, what we're making is pretty good, and we're actually almost done, really. So let's take a little drink, a little break. We'll just kind of chill for a second. We've been programming for 3.5 hours now, so like a little lunch break. But yeah, like we're doing good so far. If you're following along, like you'd almost have a game done. And I'm sure you've learned a lot at this point about how like collisions and boundaries and creating objects and all that stuff works. So let's give it a little second and we'll come back. I don't want to end the stream, so we'll just kind of sit here for a minute while I go and do a thing or two. But we're gonna take a little lunch break. All right, we're back, but we're listening to the song before we continue. All right, we're back. Had a really good PB&J, and then I came back and the song was playing. And I was like, I really like this song, so we're just gonna sit through the song. I kind of clicked around a couple things. All I really did is like delete some comments and stuff. I didn't really change anything. So yeah, we have our game. We can shoot. We can move. We have an enemy. We have a ground. We can't jump off the screen, right? So the question is, can we jump over the enemy? The answer is yes, which means that our movement is good enough. So we can avoid it on the ground. We can avoid it in the air. Playable. Am I right? But there's no punishment for being touched. And we're not doing anything by shooting the enemy, right? So the first thing is, for convenience sake, let's make it so we can shoot the enemy first. We'll worry about dying last, okay? So we need collisions. And we need collisions between our bullets and the enemy. But before we do those collisions, we need to have some kind of like health bar or value or something for our enemy, right? So I think what we'll do is we could make like a dynamic health bar and stuff, but that'll take quite a bit of time to do, and we have some other things we want to implement. So I think I'll just do some text. Let's make some health for the enemy, right? Let's start it off at like 1,000. We'll see if that's good enough or not later. And then we need some health text. Do we? It's probably fine how it is, right? But we want to draw the health onto the screen. So after everything, let's choose a fill style, right? And for now, let's go with black. I think it'll work well enough. Let's do a can fill text, which might be string, but I think it's text. And what text are we doing? We're doing the enemy.health, right? But we don't just want a number, we want to give it kind of a prepended amount of text so we know it's the enemy health, right? And then we need a position for it. So let's do 0, 0 and see what happens here. If I restart, we see something. It's like a little dot here, but like we don't see the text, right? Text is really interesting on the canvas. Instead of starting at your top left and drawing out from there this way, you start here, well, I guess like here, and you build up that way. So you're starting at the bottom left corner of the text and then drawing up from there. Now you might think, okay, but how do I know how far down I need to shift this thing? So let's do like 15, right? Now it's on the screen. It's also green because I misspelled style. But anyway, now it's on the screen because we moved it down 15 pixels, right? So for one, let's add like 15 pixels of padding to that just because. And then we want the text bigger for one. And then we also need to know how far down from the top of the screen we need to move it. And how you can do that is you can change the font that the canvas is using. So we're going to say con dot, I think it's set font. And we can do something like Arial. And then there's a number value here that is like, is it italic? Is it bold? Is it regular? I think this is regular. This is bold. And I think this is italic. And then there's like different combinations that go above that or something, I think. But we're going to try like bold. And then the font size. This is going to be like the height of the text here. So let's try like 24. And then let's add, actually, you know what? Let's just do 24. Let's just do 24 for now. We're going to restart. Set font is not a function, obviously. Who thought it was? Let's Google set font HTML canvas. Started typing JavaScript. Okay. We're silly. It's can.font equals. So it's kind of like fill style where we're setting a property. But here I can say it's a 24 pixel Arial. Okay, that should work. And then let's see what bold would be. Bold 30 pixel. Okay, so bold 24 pixel Arial. All right. You can also use numerical values. 700 is bold. Interesting. Okay. Well, we've done enough playing around with that. Now it's 24 pixels and it's bold, right? Now we can kind of play around with this too, try and situate it a little bit. Let's move it down a little bit. So we'll say like +5, maybe like +10-ish. Okay, that seems like a decent place for it, right? So now we know the enemy health is 1,000. We need to be able to lower that health, right? So let's work on the bullet collision now. So we're in process collisions here. And we're going to say like bullet enemy. So we know what's colliding here. So first of all, we need to do this for every bullet that exists, right? So for no. Bullet dot for each bullet we need to check if the bullet is touching the enemy. So we're gonna say if bullet dot x plus bullet dot width is greater than or equal to enemy dot x. That is our first constraint. So if the right side of our bullet is greater than the left side of our enemy, and the bullet x is less than maybe equal to, I don't think it really matters, it's gonna be like a pixel difference, but we'll find out. Enemy dot x plus enemy dot width. So this is checking if the left side of our bullet is less than the right side of the enemy. It's basically what's a good way to explain this? If it could simultaneously touch the left side and not be on the right side of the enemy, then that's colliding as far as X goes. Now we could break this out, do another if, and put that inside there. I'm just gonna keep chaining it. Just know that we are going to the Y checks now. So if bullet.y plus bullet.height is greater than or equal to the enemy.y, so if the bottom of the bullet is lower than the top of the enemy, then it's possibly touching it. And bullet.y is less than or equal to enemy.y plus enemy.height. Okay. So these 4 constraints make up like the perfect collision of if I'm touching this from any direction, it will trigger this if statement. But if I'm not touching it, it will not trigger it, right? So this is the X constraints, this is the Y constraints. Like, if you want to go through it, kind of figure it out yourself, I'll do that a bit on your own time, but definitely try and remember this. This is the collision you'll be doing for most of the things in your game, because most things are square. We're not going to be working with circles, but if you're wondering how to do circles, you would use the distance formula from the origin of the circle. So if the distance from whatever you're like colliding with or whatever is greater than the radius of the circle, then obviously it's not touching, right? So anyway, that's just kind of how that would work. But now we have this collision. We want to say enemy dot health minus equals 1, right? Because the enemy should take health when it's touched by a bullet. Now, this is where it can get kind of iffy, because we're allowed to have 50 bullets, but if we make a 50th, we delete the oldest one, right? But if the bullet touches the enemy, we don't want the bullet to exist anymore. We want it to disappear after it does damage. So we could just delete the bullet, which would make it undefined, which I think we might do. But usually you would want to take the bullet out of the array entirely, just to like try and keep loops shorter, because even though something is undefined in an array, it will still be looped over and attempted to be drawn, basically. And so it might even generate some errors if we just delete it. There is another way we can do this, which is probably better. So I think we'll do it that way. We will give bullets an alive boolean. Okay. And then if the bullet is alive, then we'll draw it. Okay. Where did I put that? Is alive. Try and be a bit more consistent. So now, if it's alive and it touches the enemy, so if bullet dot, let's actually just put this outside. We want the first check to be if it's alive. If bullet dot is alive, and we can even say if it's not alive, just continue. That's a pretty good way of writing it. So if it's not alive, we're not going to process collisions with it, and we're also not going to draw it. So it basically doesn't exist. And when you launch a new bullet, if it's the oldest bullet, it's going to get deleted anyway. So this is probably pretty good, pretty decent way of managing it. So let us give this a try. I broke it. If not, bullet is alive. Continue. What's wrong with this? Does for each not have a continuum? Let's just wrap it then. So if it's alive, then we'll do a collision check. Okay. So now when I shoot the enemy, it actually takes damage. But it's not turning off the bullet. So we need to say bullet dot is alive is false. There we go. So now when it touches the enemy, it should appear to disappear, which it does. Nice, 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 nice. So now we've got bullets hitting the enemy's losing health when it touches the bullet. Nice. I think we should give the enemy a bit more health. This is a bit too easy. Let's give it let's try 10,000. That should take you a while to finish. Maybe even 5,000. 10,000 might be a lot. Let's do 5,000. Okay. Now, one of the last pieces of the puzzle. When we touch the enemy, we should die, right? And there needs to be some kind of like win the game, lose the game sort of situation, right? So what do we want to work on first? How about we say let's do an is alive on the player and the enemy as well. Is alive. Okay. And then we need, as part of our update loop, that if maybe we do it like down here. So if enemy dot is alive, if it's not alive, then let's write some text. How about that? No. We'll put this in render. We'll put it here. If the enemy is not alive, then we're going to make some new text. We'll make it green, maybe. And we'll make it like 50-point font. And we'll say like, you win. You win. Okay. And the positioning, we need like 50 for the text. Okay. And then we only want to draw the enemy if the enemy is alive. So let's try and mix some things around here. Let's cut this, put it here, and we will put this up here. Okay. So if the enemy's alive, we'll draw the enemy. If the enemy's not alive, then we'll say we won, right? And then we will need this constraint on when it touches us. It has to be dead as well, or it has to be alive when it touches us. And then for the player, we'll do a similar check here. We'll say if not player dot is alive, else. So if the player is alive, we'll just draw the player. If the player is not alive, then we will make some red text that says you lose. How about that? So when I refresh, we broke something. It's because is alive doesn't have a quote thing or a whatever semicolon. There. Did I do it on the other one too? No. Okay. All right. So now the enemy and the player can die, and we'll get a message when they do. I also only want the enemy's health when the enemy's alive, right? So this was the enemy's health. We will put it here. And we'll say health. Okay. That should do pretty well. And then we might need to move this. Let's move it to canvas offset height divided by 2 plus 25, something like that. And then we'll just have to play with this one. It's probably going to be like 300 or something. So yeah, we have some messages for when things die. Now we need to make it so they can die. So if enemy dot health is less than or equal to 0, then enemy dot is alive is false, right? Because the enemy will have died. And so if the enemy is dead, then it can no longer touch us. It shouldn't be drawn. We should get a message saying we won the game. And that should be relatively good enough as far as the enemy comes. For us dying, that would be a collision trigger. So here we can say enemy player, and we will do a similar thing for our as our bullets, but with the player and the enemy. So if player.x plus player.width is greater than or equal to enemy.x, and player.x is less than or equal to enemy.x plus enemy.width, and player.y plus player.height is greater than enemy.y, and I spelled player, and player.y is less than enemy.y plus enemy.height. Okay. It's a lot to wrap your head around, but we get there eventually. Then we want player.isAlive to be false, unfortunately. And one other constraint that we need to take into thought is we need, when the player dies, we need bullets to be empty. We don't want to kill the enemy after we die. Like, that'd be kind of strange. Like, it can still happen even with us writing it like this, but it will be less likely, right? Actually, it might be impossible now that I think about it. So anyway, so that will clear up our bullets, and then also we do not want to be able to shoot bullets when we're dead. So if the player is shooting and the player is alive, then we will shoot bullets. Let's try and think of other things that can come up, right? So the enemy touches us, we die, we can't shoot anymore, our bullets disappear, it says we lost the game. I think that's pretty decent. I think we pretty much wrapped that. When we kill the enemy, it will go invisible, it won't be drawn anymore, we'll get win text, and then did we do that check on the collision? I don't think we did. So yeah. We need to say if the enemy is alive, then it can touch us. If it's not alive, we don't want it to be able to touch us and kill us, obviously. So technically, we will still be here and the enemy will still be here if either one of us die, but we won't be drawn anymore, and so it'll give the illusion that one of us is gone, right? So let's kind of try that. Well, we got touched, so we lost, right? Let's maybe change the color of that. Let's do, is this the no, it'd be this one. No, that's the victory. This is the lose. So instead of red, let's try like brown or something. Pretty standard colors. So now we get touched and boom, we lost. We are drawing this after, or like the enemy's being drawn after this. Let's maybe do, can we do the enemy before we do the player? See, this is where the layering stuff comes in, where it's important what order you draw things. So now if I get touched, you can always see you lose because it's in front of the enemy now. And we actually positioned that really well. I just randomly guessed 300 and that fits pretty good. Now the hard part is we basically have to win the game in order to get the other message. Now I can either sit here and play the game until we win, or I can go to enemy and I can just say, well, it has 1 health. And then, pew, we won. Maybe we should center that like the other one. That'd be a lot better, wouldn't it? Oh, we're still making the enemies disappear when they're touching the enemy. Let's only draw bullets if the enemy's alive. So if enemy is alive, then we'll do this, right? It's the wrong brace. Okay, so we'll only draw bullets if the enemy's still alive. And so we shoot the enemy, bullets are gone. We're not gonna have any way to see that the enemy's still technically there, right? So let's change the win to be 300 and this. Let's try that. Okay, let's move it up a little bit. Let's increase the size maybe a little bit too. I want to be like rewarded when we win, you know? We might even need to subtract like 30 or something from this. Okay, maybe not subtract. Let's change this to like 240, something like that. A little bit more to the right, maybe like 260. Okay, that's decently centered. So now we win, and we can jump around in victory. And then we can also lose. And we can't shoot bullets anymore. We can't do anything, like we can't see anything. So that's pretty good, pretty good. I feel like I'm forgetting something. Let's make a reset button for one. So we can just put this in like key down or something. We'll say if e.keycode is, I'm just gonna say 32, so it's not gonna give me an error. Let's log e, and let's try r. R is 82. Let's do 82. And what do I want to happen when we push R? Well, I could do a bunch of like resetting values, trying to set the positions back to the beginning, all that stuff. Because this is a simple HTML JavaScript game, instead of resetting all the values myself, we can just say location.reload. And oh no, I lost. You push R, it reloads the page. And you can play the game again. And it automatically resets all the values back to their defaults because the page is loaded again. So I just made R my reset button to just refresh the game, basically. So if you don't move, you're gonna die immediately and you're gonna have to push R. So let us see. We need to put the enemy health back. I think that's what I was forgetting. Let's put it to 5,000 again. And yeah, it's at this point that everything looks like it's working, right? You don't know that it's all working though. It just appears to be working, right? So what you need to do is you need to maximize this. You need to push R, and you need to defeat the enemy without dying. And if you can do that, then perhaps the game is working properly. But like, try to do a lot of random stuff. Try to like touch the enemy from all sides. Try to abuse how the bullets work in some way. Try to if you have like a lot of platforms, try and jump into the platforms from different directions. Try holding your jump button, see if there's like some kind of abuse of that mechanic that you can find. But like, so far as this game goes, it seems to be working as intended. So we just need to see if it will continue to work as intended. Let's not die. But yeah, I made this game when I was in high school, and I called it Cube Wars because everything was a square. And I distributed it to all my friends, and they played it like all year long. Every time I saw them in the computer lab, they were playing this on like second monitor or whatever. So of course, some of the values might be a little bit different as far as like player speed and stuff, but the general concept of this game I just kind of came up with. It's a simple idea that pretty much anyone can make. And I was learning a lot about game development at the time, so it was a good way for me to test my knowledge of that stuff. We'll just hide in the corner. Okay. But yeah, I mean, it's a pretty simple game. We made it in 4.5 hours basically, and this is like this hits the dopamine receptors, you know. And I think that's kind of the goal. Because you can't exactly stand still, because we made it so the enemy moves in kind of an erratic way that it'll hit everywhere on the map eventually. Oh, we have almost got it. I just gotta not mess up. And it's like, it's a one-hand game. You play this game entirely with your left hand. You don't need to involve the mouse or anything. So you can like do something with your right hand or whatever in the meantime, like eat some food or something, you know. But yeah, this is a very simple game. I think pretty much anyone can make, and we're just about to win. Nice, we did it. GG's, guys. We won. We're game programmers now. Officially. So yeah, we beat the game. We know we can lose the game. We've done that enough times. Trying to think, like, I know a lot more game development stuff, but there's not a lot that I can put into this game just to show you, because you'd kind of have to write a different engine or write it in a different language or something. Like this is plenty, honestly, to entertain yourself, entertain your friends, and you didn't need a server or anything. All you need is this one HTML file that you put on your desktop, and you just open it in Chrome or something, and it runs. And then you're like, oh well, I opened the game, right? And then like I immediately died. Like, what do I do? Whatever. And it's like, well, keep your hand on the keyboard. You just push R and then you move. And if you mess it up again, you push R and you move. Like, it's really easy to reset and play again. It's not like you needed to design menus or anything. Like, the game is very straightforward, so long as people know the controls, right? So you just tell them WASD and spacebar to shoot, and like they'll figure it out. And if they're like, oh, I don't like reloading the page every time I want to play, you tell them R. And they're like, oh, wow, that's really easy. I just push R and the game resets and I can play it again. So you can make like a leaderboard. And you can say like, you know, where the enemy's health was, or maybe if someone completes it, then you want them in like a completed players list kind of leaderboard sort of thing. You can do that. And I'm pretty sure that you can save those values in cookies, even though it's a local file. I'm pretty sure you can do that. But I'm not positive. But if you do need it hosted, like you can just get a simple Apache server or something that's really easy to install, really easy to just move this HTML file onto it. And then you can make a leaderboard. You can like, you know, use cookies for other things. My friend wants to make like an idle game where like as time goes on it like ticks things up. It's kind of like Cookie Clicker, right, where you bought factories and it makes cookies for you so you don't have to tap it anymore. Like he wants to make something kind of like that. And I was telling him, you know, if you just want to use like cookies for that, that's perfectly like valid. You know, you don't need to set up a database and all this stuff for it and get really complicated with it. Like you can just save it locally to your computer and then just make the cookies have like a really far expiration date to when you're probably like not playing the game anymore, or just make it so it updates the expiration date every time you save the game or whatever, right? So there's like tons and tons and tons of things that you can do with the stuff that I've just shown you. And if you want to do images, one thing you could do is you could make like an image tag here, and then you can use in your rendering stuff, you can write can dot, I believe it's draw image. And then the first one is going to be the image that you're drawing. And so if you loaded it with like new image or something like that, then you could put it here. Or if it's already on the page and you have a reference to it, I believe you can do it that way too. And then after you have your like image reference here, it's again basically the same thing as fill rect. It's just X, Y, width, height. But there's also more variables you can do. You don't have to add the optional ones. But if you do an additional, I think it's 4, this will crop the image that you selected to be these pixels of the image. So if you have like a sprite sheet, then you can load the sprite sheet into memory that has like multiple images on one like bitmap or something. And then you can say, well, I want to draw the sprite sheet at this position with this width and height, but I only want to draw this part of the sprite sheet. And that's incredible, because a lot of times you need to make like an image loader and stuff too to make sure all of the assets have loaded into memory before you try to draw them. And so the fewer images that you need to fetch and load, the better. So sprite sheets are really good for this kind of thing. And you're only having to keep like one image in memory and manage where it's located in your game and all that stuff. It's like that's really useful, and I'd definitely look that up if you're curious about how to like do images and things. One thing some people like to do is instead of clear rect, they like to use fill rect and just fill with white or something. It'll accomplish the same thing as what we have, but I think clear rect might be more efficient, and that's why I use it. And then another thing to keep in mind is you don't have to like you don't have to use images. You can draw the context of a canvas onto another canvas. So you have like canvas inception. It's like really cool, and you can do interesting things with it. So what's an example I could give? Let's say you have like an open world and your player is in the center of the screen and it's like top down, and so you're walking around, right? Well, just to change the direction you're facing, maybe you want to face the mouse or something. I could show you how to do mouse events too. But you want it to face the mouse, right? But every time it turns to face the mouse, you have to redraw the whole canvas, right? Wrong. Because you can put a canvas that's only the size of your character, and you can put that in memory, or you can put it somewhere else on the page and just hide it or something. And then you can only redraw that canvas. And then whenever your canvas, like your full canvas, refreshes or whatever, then it'll draw that new little canvas there. And I've heard that that's more efficient. Logically, I don't know how, but it appears to be more efficient, at least to some people. But that's pretty cool. You can do a lot of different things by putting canvases in canvases, and you know, all kinds of mathematical patterns and things you can draw on canvases, like sine waves and all that I kind of showed you. But yeah, I think one more thing that I will probably show you is mouse events. It's very, very, very similar to our keyboard events, but you would say document actually, there's a couple different ways you can do this. What I would probably do is canvas. So you're targeting the actual canvas element. Dot, we'll say like on mouse move, I believe is one. And then we will console log E, right? So let's take a look at this. We move the mouse, and you can see the numbers. If I go up near the top left, I exit, come to the console, and then I look at these values. We can see client X and client Y. And then we have like offsets and screen X and screen Y. So this is the pixel of my whole monitor. That's where it is on my monitor, I believe. It might be the window of the browser. That might make more sense. I'm not sure. But there's like client X, client Y, page X, page Y, and all this stuff. You can play with these numbers, and you can find out which ones are like relative to the canvas itself. Because there should be one that's like almost 0, 0. when I'm putting my mouse over there, it we made a lot of events. So it's probably the client X, client Y. Is probably the ones you'll be working with. But you can use this to figure out where the mouse is on the canvas, and you can use that to help with like menus and things. Because if there's a collision between the location of your mouse and the button that you've made, then you're hovering over the button. So that is how you would make like a menu hover things. You can like change graphics or something. In addition to on mouse move, there is an on mouse enter and on mouse leave, which is like when you enter the canvas or you leave the canvas. But I don't think those are that important for a game where you're probably going to be constantly interacting with the canvas. You're probably never going to leave the canvas. But if you want to make something fun or make it so it pauses the game when you leave the canvas or something, I could see that being useful. But there's also on mouse down, I believe. Maybe. We will find out. Console log E. There's something that's like on mouse down. So we'll refresh. If I click, yeah, it is on mouse down. So if I click, that's mouse down. And it only triggers once, unlike the keyboard on key down. It will only trigger once. It won't continue repeating. And this will give us similar information. It'll tell us where we clicked on the client, X and Y. And so in that case, you could say like, if my mouse from the on mouse move is colliding with a menu item and mouse is down at that location, then you've clicked the button on the menu, right? There is, yeah, I think this which here, that is which mouse button I clicked. So like I just right clicked there and it's which is 3, right? Or if I click my scroll wheel, then it is 2. So left is 1, right is 3, and which is, or clicking the mouse wheel would be 2. So if you want to know which mouse button was pressed, you can do it there. I believe button, maybe not. Let's look at the other buttons. Button might also be different depending on which one you do. I don't even see button in this one. Yeah, I would use this which one because it seems more reliable, and I know that it's different depending on which key or which button you press. So you can do like left click, right click, or if someone clicks the scroll wheel. There's also events, like there's tons of these events that you can put on elements. Like you can do on scroll, you know, all that kind of stuff. But as far as a game goes, scroll would be kind of difficult in a browser, because unless you have it set up like mine where it's not bigger than the browser itself, like if I went like this and then I scrolled, it doesn't do anything because I don't have an up and down scroll. But if I, for instance, went like this, Windows, I hate you. But if I go like this, then my scroll by default scrolls the page up and down, right? So I don't want the page to scroll up and down and have something happen in the game when I scroll, because then I'm going to be fighting between like keeping my self focused on the game and also trying to stay on the page where I want to be and all that stuff. So like that can get really frustrating, and like you'll figure that stuff out just through like usability testing. Like just play your game, and whatever doesn't feel good like get rid of it. You don't need it in the game if it doesn't feel good, you know? And yeah, also try playing the game on different computers. Try playing it on your phone if you care about that. Uh, Send it to your friends, see if they find any problems with it. Like, you need to do a lot of testing to make sure that your game will run on a bunch of different devices, that everyone can intuitively understand how to play your game. And like, this game doesn't really accomplish that very well, because I don't have like a what buttons do I press sort of instruction or something. But if I wanted to, I could just add some like paragraphs in HTML like down here that tells you how to play the game, right? And that'd be really simple, and people would jump in the game, they'd know how to play it immediately, and then they're good. They just play the game, right? So really just think, and like, because this is HTML as well, I also really want you to think while you're designing the game, what needs to be inside the canvas, like drawn, and what can you just use already existing HTML elements for? Because we need a canvas for this, because it refreshes like 60 times per second. But if you just want to make a menu, or kind of like my friend wants to make that idle game where like things just increase every so many seconds or whatever, you can easily do that just with HTML elements. You won't need a canvas for that. And all you would do is you would grab the elements the same way we grabbed this canvas, and then you just say like dot inner HTML or dot inner text or whatever, and you would change it. And so you could do that to regularly update values that are on the page. And then you could have actual buttons, and the buttons would have like on click functions that do whatever. So it'd be a lot more event based than frame rate based like this game is. But there's tons and tons and tons and tons and tons of different kinds of games that you can make. And there really isn't like too much of an upper limit. The only limit, I would say, is like basically browsers have, I think, like a gig limit per page or something for memory. So if you're like shoving all kinds of stuff into this game to where you're actively like manipulating a gigabyte of memory, like you're probably going to have some issues. But I do also know that most browsers these days support something called WebGL, which is like a web implementation of OpenGL. And as far as I know, like you can fully utilize a graphics card and stuff in that in someone's browser. So there's very few things that you cannot make just in a browser game. You just have to know how to do it. So I think some final kind of notes about the game and stuff. If you want to save data, one way you can do it is with cookies. Another way you can do it is with like PHP or some other language like that. But JavaScript, I think they have a local storage thing now too that you could probably look into. But that's probably similar to cookies anyway. It wouldn't be that different. But yeah, look into like PHP and SQL, which is SQL. Get you like a MySQL or MariaDB database or something to work with that. And all this stuff is free. You don't have to pay for like any of this stuff. So if you ever wanted to get into this stuff, like just jump into it, see what you can make, see if you can figure it out. Like there's no downside to trying to figure this stuff out. Like it just takes time, and what else are you doing with your life? um Having friends. Who needs those? Program. um Taking a little drink while I think for a second. Yeah, so if you wanted to save data, I would look into PHP and SQL. I think that'd help you a lot. For some games, you will need to learn Ajax, which is Ajax requests in JavaScript. We have a new API for that too, and it's called Fetch. And it's a little bit confusing for new developers, but I think it is a pretty good payoff after you figure it out. What else? I fucking hate Python. Please don't learn it. Node is kind of like Python as well, if you're ever interested in that. Like, I'd recommend Node more because it's JavaScript. And so if you wanted your entire game to all be one language essentially, then Node would get that done. But I don't like it because of its packaging system. Similar to Python, where like people just download packages for everything and they don't know how anything works. Like I find that kind of frustrating to me. But yeah, I intend on making a GitHub that anything we program on stream, I'll upload to that GitHub, and I'll probably have that in my description after I do. So if you ever wanted to like go back and find a copy of something that we've made, it would be there. Yeah, I don't know. It's like I don't know when I'll be programming more, like if I will. But I did study programming and like game development and stuff for pretty much my whole life. So I do have a lot more that I could show you, and other languages that we could program in, and different kind of like data structures and things that I could show you, different ways that you could manage your code. So yeah, I do enjoy making games. Even just making games I've made before, I still think is fun because it lets me kind of look back at how I used to do things and how I can do them better. Like these days, you know. So, but I think I will probably wrap it up. I will likely be streaming tomorrow. Like my ideal situation is that I stream Monday to Friday. I just don't know exactly what I will do. It's kind of whatever I feel like doing in the morning. I've been playing League of Legends, doing a like ranked climb. We're Emerald 4. We were Emerald 3, and then Riot completely tanked our games for us by giving us auto-filled teammates that just don't care about the game at all. So we lost all of our LP, but hopefully we'll get back. Our goal with that is basically Diamond, so we really weren't that far from it. And honestly, we will continue climbing if I keep playing. So we might do that like tomorrow. But if anyone's interested in like seeing programming stuff or has programming questions or something, like I have no problem ending League early to show you, or just answering your question while I'm playing the game. And kind of vice versa. Like if I'm programming and you have a question about League, like feel free to ask. I'm not like the best League player ever, but I am kind of higher elo. So, and I've been playing the game for like fucking, I don't know, 7 years or something. It's been a long time. So I do know a lot about the game. But yeah, I think I'm gonna wrap it up there. Um, thanks everyone for coming. I hope you learned a lot from this, and I hope that you've been inspired to go and make like your own kind of game. Um, we may even make another game like this, but with like graphics and stuff, and it'll be kind of a different sort of gameplay style on a different day, but just not today. um, and I'll have to make graphics for that and stuff too. So maybe you can kind of see like the graphics sort of development cycle and things. And I'm not a digital media artist, but I can do enough to get a game going, you know. Music is the one thing that I'm probably not gonna be able to show you anything about, but I can show you some free resources to get some free music that you could put in your game that's like non-royalty, non-copyright sort of situation. And I think those are great to put in your game. It really saves people a lot of time and it adds a lot of like ambient feeling to the game. Because this is a nice little office game where like you're not trying to make noise, you're just trying to do something on the side. But if you wanted to actually be involved and immersed in the game, I really think the audio plays a huge part in that. Um, but like I was saying, like you don't have to make that audio yourself. You can find it. You just have to find something that fits your game's vibe, basically. Um, but yeah, I don't know. I'll just keep talking. So I think I'm gonna wrap it up. I have a ton more I could show you if you're curious. Just let me know, and I will be back tomorrow most likely. Thanks again, everyone, for coming. If you could follow me, that would help a lot. I'm really trying to get affiliate. I just realized the affiliate thing's been on like the top part of the game the entire time, but I'm sure you could tell what was going on. I might move that for next time. But anyway, until next time, I'll see you all later. Bye.